supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
What's up, everybody?
My man.
Let's go live on all things. Dun, 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 dun. All right, nice. Good on that. Let's activate this source. Sick. Yo, what's up? Don does math. Don does raids today, dude. Right on the... I just started streaming, dude. Nice. 1 sec. Let me get this running. TikTok's up and going. Cool. Good. Oh, I need my... Why is my chat not working, though? Come on, chat. Oh, I need to, I think, activate my Twitch. Yeah, this should be working. Fuck. It was very good timing. Nice. Sick. Yes, and we got Sir Sensation here in his house. Let me get you up a little bit bigger. There we go. What was going on in your stream today?
It sounded a bit distorted yesterday.
Oh, did I sound distorted? On what? On which platform?
I sounded distorted when I watched back the VODs.
Oh, you sound great. You don't sound too distorted to me. Maybe I need to turn your volume down a little bit. So let me see. I mean, you're fine on my side. It's just probably how my thing is going through. Whoa, is this new, or have I just not been early to a stream? Yeah, you haven't been early to a stream, Don. That's okay. Yeah, that's my intro thing. Sensation actually came up with that, right? Yeah. Cool. And I think this chat's working. Let's see. Welcome, YouTube. That one works. Cool. It goes hard. Yeah, it's AI generated. He came up with like an AI script for it. And then I think all the music is AI as well. It is pretty... What was the actual the prompt you used for it, Sensation?
So I wrote some lyrics, and then I dumped them into Suno.
Did you actually write the lyrics? No, you had AI write the lyrics, though, right?
No, I wrote the lyrics.
Oh, you wrote the lyrics? Really?
I wrote the lyrics.
Oh, that's fucking dope. Dude. What? I didn't know you had bars like that.
That's dope.
Wow.
Anyway,
I didn't know that.
Now gone.
I don't know. I didn't know you actually. I thought you just said like make a whatever math thing, and then it would do like the lyrics and it would do the whatever.
No, I got told off for that in English all the way back in year 7. Everything I wrote seemed poetic.
Oh wow, wow! I learned something today. That wow, yeah, our intro song is not AI generated lyrics. It's. I mean, the music's AI, but you actually wrote the lyrics. That actually makes it even cooler. I didn't even know that. That's dope, dude.
That's dope.
I would have done the music, but it's like I haven't used Fruit Loops in millennia.
Mm-hmm.
And there was no guarantee it would be any
FL
good.
Studio. Yeah, no, it sounds pretty good. Yeah, Famish is asking if you use Suno. I think you said you use Suno, right?
Yeah, that's what I did. I
nice. Yeah, he
just wrote something in Notepad, told it where to split it. I put, yeah, anyway. And then I put it into Suno and it went, there you go.
And now that's how we have a dope ass song. I should actually release that song
10 times to make sure.
I should. Oh, you did 10 iterations and did you pick the best one out of the 10?
Yeah.
Oh wow. That is what you have to do with AI a lot of times. You have to like do multiple iterations and then you pick like which one is the best. Seth, what's up, Seth? Good to see you. Wow, that's really cool. Yeah, today's Tuesday. Awesome. It's final exams for some students. I sent off hopefully my last lesson with one of my students at Pepperdine. He's taking his statistics final in an hour. Like, pray for him, because I've worked with this kid for so much time and I really want him to pass.
Sorry, Seth. You were still muted from the other day when you were arguing with
Oh,
that
yeah.
dude about.
Oh yeah, let's unmute
bases.
Seth. Sorry. Yeah, let me turn his volume back on. Sorry.
He's
Yeah, there he is. He's back. He's back. I can hear it. Seth, I can hear you now.
my bad.
Oh, that's not your bad. Yeah.
I forgot to unmute him. That's
Yeah, that's okay. That's okay. Well, Seth's a mod. I think he can unmute himself, but
I cannot.
you can't.
No.
I was
I
not a
did
mod.
Well, you're a mod though. What the fuck?
Nope.
Okay.
but,
All right. Whatever.
but I'm a god
Okay.
mod.
He's a god mod. Yeah. Yeah. That was just because I had to end the stream and y'all just kept talking about base 7. I was like, I need to end it now, and so it's all good. Welcome. We do have some good questions actually. Do you see Seth already? Like we're getting some web questions already coming in. Look
Yeah,
at this
I
one.
didn't see those.
Look, sine x, sine nx over the square root of n
Period.
plus x. Ooh, this is about to be interesting. It's gonna be really interesting.
Oh, that's Hey, wow, that was good.
Other Ion says, I just started analysis 2 this semester. I have an assignment. One part of the question managed to show, but I would like to ask about the second part. You totally can. Is this your analysis question, Other Ion? Is this you? No, this is Federico Agostino, apparently. Oh, there's Other Ion.
Okay.
I see his. One sec. Oh wait, nothing on my Discord is loading. Excuse me. Discord, are you okay?
Yeah, Gold. You're gonna hate me for this request then.
Oh, what's up? What's a request?
If
Drink
you
more.
if you think that's cool, you're gonna hate me for the request. The request is, could you give us plebs the 411 on not integration, the other one.
What's the other one? Derivatives, right?
Yeah, could you give us the 411 on derivatives?
The 401 on derivatives. No, derivatives are really cool, actually. Yeah, no, I like derivatives. Yeah, so derivatives are really cool. Derivatives, because someone actually just asked this as well on one of my YouTube videos. But derivatives are really good for figuring out the instantaneous rate of change, is what we say. And, I mean, life is all about change. So things are changing all the time. So what better thing than to have a math that is 100% focused on, like, how much do things change? Yeah. I like to say it's like slopes on steroids, is what it is. Because, in basic high school math classes, we learn how to take the slope of very basic trends, so basically lines. And this is cool. Like, we can figure out, like, a slope that you guys always do with, like, I don't know, it's like rise over run, like delta y over delta x. So you've already done slopes. You've already done derivatives if you're in high school. Maybe even middle school. You've probably done, like, slope of a line. This is just, like, a very simple derivative because it's for something that doesn't really curve or anything. But life is not so simple, unfortunately.
Wait, so y equals mx plus c.
Good. Yeah, no, exactly. Y is equal to mx plus, we use b. Do you use c over there on,
B,
on the east, on the
Yeah,
other side of the pond? Yeah.
B's fine, whatever.
Yeah. So this right here, this is the slope. This is also the first derivative of a line, is what it is. It's actually pretty cool. Life is simple with ChatGPT. I mean, it can be sometimes. So yeah. So you've already done derivatives. What calculus does is allows us to now take the derivatives of, like, weird, wacky curves. And we can find those derivatives anywhere by doing, like, a lot of really cool tricks and stuff. That's, like, the short reason why they're cool. It's for, like, rate of change. Some applications for why they're really cool is that if you have, for instance, a curve of something, let's say, for instance, you're doing, I don't know, like something like this. And this is describing, I don't know, let's say this is describing your weight over, like, different days in the year, Let's say, for instance, like this is around, like, Christmas, I always gain so much weight around Christmas. And then this is, like, the summer, right? Okay. If you wanted to find, for instance, what we call, like, the optimization, so, like, the maximum and the minimum of what things are happening, you can look at what's happening to the slope or the derivative or the instantaneous rate of change at different points. So, for instance, if we use these purple arrows to describe what the slope is at different points in time, I'm just gonna, like, draw a bunch of these. Are called tangent lines, is what they are. But these arrows here represent what the slope is at, like, for instance, here, 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 and here. what we can do with this is we can figure out where we are our heaviest and where we are also our lightest, you know, summer bod season, right? So this is called a local min. No matter how many times I stop by, I'm always on a streak of 3. I don't know how that works. Because our streams are usually, it's 3 and then there's a break. And I don't usually do things on the weekend, but okay. But anyways, maximums happen when the derivative or the slope goes from positive to 0 to negative. And then minimums happen when the slope goes from, or the derivative goes from negative to 0 to positive. So if you're able to calculate what the derivative or the slope is of a function at different points in time, you can then figure out where the maxes and the mins are. And that's why derivatives are really, really cool. Oh, I think they're cool. That's why you use them.
Does this relate to... Sorry.
Yeah, no, you're good. What was your question?
The I can't even describe it. I don't know enough.
No, it's okay. Just like use your hands or something.
The algebra part of it, where it's like, this is x, and it equals something, and then the derivative of x, so...
Good.
dx.
Like a function?
And then
you're talking about like...
something.
Yes. No, it does. Yeah. No.
X is equal to such and such, and then dx is equal
Yes.
to such and such, because you've done something to x in order to get that. And,
Good.
but
Yeah,
then
no,
they
I'll go
always
into that.
showed it as dy over dx, and I got confused.
Yeah, no, for sure. So usually, let's say for instance in here, right? The red thing here would be, for instance, this would be called like f of x is equal to something, which is usually like y is equal to, I'm just going to come up with some like bullshit numbers. Like, I don't know, like 3x squared plus 2x plus like 1 or something. That doesn't fit this because it's a triple bump, whatever. Yeah, this represents what the actual function looks like, what the line looks like. If you want to calculate what the slope is at different points, that becomes dy dx. Okay. Which is now a new function, which in this case would be the derivative of this, which would be 6x plus 2. And there are rules for like how to get from here to here. So this is a new function which describes what the slope is doing at different values of x. This describes what the value of the function is doing at different values of x. And that's why that's the difference between the two. One sec. I had like someone, where's my notifications on this thing? Is it on activity? Comments? One sec, I'm trying to find it. Yeah, this person right here. Someone commented on one of my TikToks. Will it load the comment though? Come on, TikTok. Choking on the comments today. Oh yeah, here. This was the comment that someone said. They said, again, why does this matter? I hate math. And what the video is that I'm doing here, this is called related rates, and related rates are very much involving derivatives. And specifically, this is how to calculate its two rate of changes that are related to each other. Yeah. dy dx is just a fancy rise over run. Yeah, it's rise over run for, I don't know, fancy people. Yeah. I have a topology exam tomorrow. Please help. Yeah. And what's up, Kushwa? Yeah, nice. I'm glad you like math. Math is great. So just a quick little, before we go into people's questions, what I was doing in that TikTok video there, the one with like related rates, is wait, not ChatGPT. There we go. Is we were taking a cone, okay, and I was seeing if I know, for instance, that a certain amount of volume of water is going in, or I think in that question it's leaking out, then you can figure out how quickly the height of the water is changing. Yeah. Oh, we got a bunch of people here. Wow. Welcome, Zach. Welcome, Zach. Yeah, I'll give you a shout out. Well, I got to give a shout out to Don first, because, yeah, Don, you rated me, dude. What's up, Don? Good to see you. I was referring people to your chat, actually, Zach, because some people were asking about sequences and series yesterday, and I was like, you're the sequences and series man. And actually, it looks like this question is probably related to something that you would be an expert for. Yeah.
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 And it is.
Right. This is definitely a series. Yeah. So we'll do this one. But to wrap up what I was saying here.
The other one is.
Oh, the other one is as well? Yeah.
I went at it. Wait, read it.
Well, it is a series. What? Oh, is this one also a series? No. This is subsets.
No, it's not
This one.
serious, but read it. It's not nice.
Yo, I know it's not nice. Sine of x times sine of nx over the square root of n plus x. Yeah. This is a weird looking. What's up, Dismal? Yeah, this is a weird looking series. But anyways, to wrap this up, if you have like two different rates here, for instance, the rate at which the height of the water in your cone is going up and down, and you have the rate at which the volume of the water is going in, you can use calculus and derivatives in order to like relate those two. It's pretty cool. So that's why. Cool. All right. I love that question. Thanks, Sensation, for asking that. It's a good like. Do you have any other like side questions with it before I go into like other stuff we're gonna do?
Not today.
Not today. Good. No, that's good. Okay, cool. All right, let's start off the stream, and welcome everyone.
Before
I crack up.
I keep
Before I
getting a
crack
bit
on.
of robot voice.
From me?
I keep getting a bit of robot voice. Am I the only one getting that?
Oh yes. Someone say, is my audio quality
Alright.
okay? I think my stats are okay. Looks like I'm pumping good audio. Y'all tell me if my vocal stuff sounds alright. Okay.
Just
Well,
every
we'll
so
see.
often it'll just go robotic.
I'm gonna go. Brr, brr, brr. Nice. Thanks for the follow. All right, let me start the
Yeah,
stream.
maybe it's just me. It looks like it.
Welcome everyone, office hours. My name's Dr. Gold, Actual Education, Stream Subs and Math, Homework, Science, Homework. Other Ryan says my vocals is okay. He says it's fine. So, maybe it's you. It's not you, it's me, babe. Oh, and then, yes, let me give a shout out to, let me see if I can give this to either to iPie. Yeah, Zach is great. He's our sequences and series master. So Zach, I might need some help on this one. Because I'm guessing we're supposed to figure out like what the value of this thing is. Is that kind of what's going on?
Yeah, I would think so.
And it's alternating and shit, right? Okay. Sir, please answer my question on Discord. It's on limits. Yeah, no, we'll get to it. Just give me a second. Just give me a second. Okay. Is anyone here interested in quantitative finance? That's the dark side, dude. That's the dark side of math. It's when people stop doing math and start just making money. Yeah, this is probably, does it converge or diverge? Yeah, I guess that's the question, right? Converge or diverge. Yeah. Okay. Someone in the chat said Dirichlet. I'm pretty sure Dirichlet's criterion works here. Interesting. I have no clue what Dirichlet's criterion is. So let me look that up for us real quick. Let's stop. Okay. Dirichlet criterion. Dirichlet's test. Okay. Let me just read what it says here. Okay,
I really can
Dirichlet.
be horrible sometimes, people.
What's horrible?
The dude that was like, you know, you got the interest in finance, and I was just like, sorry, Pride's in June.
Pride is in June. Oh my god. Okay, here we go. So, it's the alternating series test. So is this just showing that like if something is alternating and it's decreasing, then it's okay? Then it must converge? Let me see. Okay. Dun, dun, dun. What's different about this than alter? And then, is it bounded? Oh, okay. Wow, this is getting like confusing real quick. This to me is like more than just like a high school question. I almost wanted to do, well, the square root of x to me like kind of messes with me. Yeah. Like, could you do the limit comparison test on this maybe? And x is between 0 and infinity. Okay. All right. Well, first of all, right, I can pull out the things that don't depend on n from my series. So that is the sine of x, right? So let's say, for instance, this is some series. S sub x is equal to this. Okay, so in order to do this, let's pull the sine of x out. So this is equal to sine of x, and then it's the summation for n is equal to 1. Let me see, let me see the chat, what's happening here real quick. Desmal says, the first part is easy as the numerator is probably obviously less than or equal to 2. The second part is a bit trickier with functional sequences. N plus x to the 1/2. Yeah. Okay. Let's see. Okay, so sine of x, sum from n equals 1 to infinity of sine nx over the square root of n plus x, right? This I see is already going to alternate, right? Because sine of whatever, as long as n just keeps going up, is going to alternate between plus and minus, plus and minus. What's up, Chantrix? So, all right. From what I'm seeing here, we want to try to identify this as one component and this as one component and then deal with them separately, I think. So we could say that, for instance, a sub n is equal to this part. So sine nx. And then b sub n is equal to this, the square root of n plus x. Okay. Or actually, no. We don't want to do a sub n over b sub n. So let's make b sub n equal to 1 divided by the square root of n plus x. So now I have this is equal to sine of x, sum from n equals 1 to infinity, and that's going to be a sub n times b sub n. The a sub n part alternates. Why can't I pull this part out of the series? Because it doesn't depend. I'm not going to pull it out of the whole thing. But I'm going to at least pull it out of the series part because it doesn't depend. So I think this is okay. Oh, is the stream lagging? Uh-oh. Let's see. What's up with... I think it is lagging. Okay. 1 sec. Give me a second. Let me try something else. Because I think for... Yeah, for YouTube, we're doing okay. Oh, no. We're getting hammered a little bit. Okay. 1 sec. Give me a second. I'm going to stop this. Stream is lagging. Yeah, I see that. We're losing it. 1 sec. Give me a second. Let me kill that. Turn this on. Failed to connect to stream. Come on, girl. Oh, wait, 1 second, because it's also going through here. Boom, 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 boom. Okay, now let's try it. There we go. Okay. Now let me kill this, actually. Let me kill this 1 sec. Okay. Check. Let me see if it's better that way. And then let me kill this. Let's stop streaming on that. Test. Is the bandwidth better? Okay. I assume someone will tell me if it's not. Let me try something. Yes, I can see. Yes, I can hear you. Here, you should see my messages. 1 sec. Here. Yes. How am I gonna do that? 1 sec. Yes. Stream works? Better? Okay. Thanks. Yeah, Slayer, I had to cut it. My bandwidth is choking. So watch on Twitch or YouTube. Yeah, I'm cutting the Discord feed. Just for bandwidth. I guess it's that time of the month. or that time of the day. Sorry, not that time of the month. Around this time, everyone just starts hammering the fucking internet. It is super annoying that they don't give much upload speed to internet connections, because that's what I need. I need upload in order for you guys to hear me. But okay. All right, here. Desmal says this doesn't work. I'm not allowed to do this. Why am I not allowed to do this? You think this might be telescoping? Oh, okay. Should we write out a couple terms? Can I do that for sine? Oh, interesting. Sine of x times sine of nx is equal to 1/2 cosine x n minus 1 minus cosine x n plus 1. I didn't know that. Product to sum. All right, so let's look at that real quick. Or I think I have it on like trig identities. And then this is going to be under whatever Wikipedia has it. You've been playing with product of sum? All right, let's see. I think he's talking about... Do they have it? What product? Product of sum. Here we go. Cool. I think we're going to use this one. Okay.
Oh wait, they're saying it's not that.
Oh, they're saying the denominator does mess it up. Oh, because it doesn't telescope because of the denominator. Okay. Let's see. Do we have an identity for the sum of sine for this? Do we have an identity? Is there some identity for this? There must be, right? Like, what is n equals 1 to infinity of sine of nx? Right? Yeah, we already know this is bounded, right? I already know 1 over the square root of n plus x. Well, is it bounded? Doesn't this fail by the p-test? I feel like this fails by the p-test. Yes, Ritu, submit a screenshot down below. We'll help you out. Why? I see. But if it's as long as it's alternating, it will at least decrease, right? And that's all we have to prove. Yeah, it is bounded. Okay. Okay. Let me see if we have something for this. Infinite sums with sines. I don't know. Infinite sum of sine. Oh, he's got one. Wow. Okay. So this was the trick we needed. So wait, he did do the product of something. Yeah, and then Dirichlet's test. Okay. Oh, wow. So here, this is the identity that they're using. Oh, this is somebody's grades. Okay. Which I think came from this, right? Okay. Dangers are getting in close. Oh, yeah. I have heard of that one. Yeah, that one is ridiculous. Yeah. Where he claimed he invented integrals from, like, Riemann sums. Yeah. Okay, so this identity here comes from this, I believe. 1/2, right. Wait, where's the n minus 1 and the n plus 1 coming from? Sorry.
Probably telescoping. Because it's moving term.
Oh, okay. Well, I want to prove that for myself, like why that is. Yo, you're that guy from. Someone's like, yo, you're that guy from that one clip. I'm like, yes, I am that guy from that one clip. Yeah, we're doing like free math and science tutoring right now. Casey Mooney. Oh, and we got some screenshots coming in. Okay, that's just product of sum. I was just interested why we get n minus 1 and n plus 1. Because, isn't theta like x here, and then this is like nx? Oh, I see. There's an x out. Oh, I'm stupid. Sorry. There's an x. We factored out the x. Okay, cool. Whatever. Got it.
Yeah.
Desmond said he typed.
He said he typed.
One sec. Someone said he typed.
You can't use that rule unless you put your sign outs back.
One sec. There we go. Desmond got something cool for us. Let me copy in this whole image. This is a big image. He typed out the whole thing, dude. Wow. Okay, one sec. Let's see if I can see this. The resolution might not be as great. Yeah, because there's kind of like a limit. Okay, here we go. We're gonna just walk through Desmond's solution rather than me like trying to reteach myself all this. Okay, here's our series. This is very quick that you, unless ChatGPT came up with this, and then that would make more sense. So Dirichlet's test, you have A sub n and B sub n, and you have to check 3 conditions. The first one, I guess, is partial sums. Okay. This is getting like really weird here. Okay. Okay. So then you check this with the conjugates. Cool. Equals 1 over this condition. Is it strictly positive for x equal greater than 0? So b of n is strictly decreasing in n. Okay. Well, you show that this. Oh, I see. That these terms will always have to be positive. So you're always dividing by a big number or greater than 0. Yeah. Okay. Yeah, this was typed really fast, apparently. Desmond says here on the just chatting, Desmond says that he typed out the solution in short, and then he had ChatGPT come up with the LaTeX code for it. But yeah, very impressive. Okay, and there you go. All 3 conditions of Dirichlet's test are satisfied. Therefore, the series converges on that. Cool. Nice. Good. Good job.
Volume-wise.
What's up?
You know the volume converges to?
The volume? What do you mean the volume?
You know the volume it diverges to?
Oh, the value it converges to. I don't think we do. We know that the different we know the elements must converge eventually to 0, right? But I don't think we figured out what it converges to. ChatGPT does love its sections, yeah. No, he said he just used ChatGPT to come up with the LaTeX code. He apparently typed all this out himself, which props to you, Desmond, if you did. Typical series problems always has some quirk to it. Okay, cool.
So
here, let's do this one. I want to do this one, and then I will start doing these other ones because I don't know. Y'all are asking. I want to do something that like I already know how to do. Some of you guys are asking some like really super advanced questions. This I feel like I could do because this is fun. I think, right?
There's a limit in there. Do you want to do the limit first, or do we want to do?
There's a limit in here. What do you mean there's a limit?
No, on in Discord. Under.
Oh, under help screenshots.
Nope, under office hours.
Oh, someone posted it in office hours. I don't see.
Posted it in the.
Oh, Zimfong.
It says the following.
Okay.
Given B is finite, A is greater than 0, determine the values of A and B so that B equals limited to 0, adds part to 0 of this. This expression defined as A minus the square root of A squared minus x squared. minus x squared over 4 all over x fourth.
I see it. Let me do that one later. I want to do this. This looks like a fun integral. I feel like this will be interesting. My gut instinct when I see stuff like this is to do integration by parts, right? Because I see something that I'll always know how to take derivatives of. And also, I don't know if I can do the integral of sine squared. That kind of sucks. I can definitely do derivatives of this. And I think this may... I think this is going to be like a repeating integral at some point. Let's just see. I think integration by parts works. I'm going to choose this part here to be my u. And I'm going to choose this to be equal to my like dv. Okay. So let's just see what happens. So if u is equal to...
We don't know what sine... We don't know the integral of sine... We don't know the integral of sine squared, though.
No, but I know the derivative of it. I do know the derivative of sine squared bx. Right? So the derivative of sine squared bx is... That's equal to 2 sine bx cosine bx. Right?
Mm-hmm. Well, what about b?
Times
what
b.
about b?
Times b.
And b is a what?
Well, we don't know what b is. We're just gonna leave it.
Well, b is a b is not x.
I know. So when I do u
So it
sum,
must have a
right?
extra term on the end of it.
So this is like u squared, right? This whole thing here is like u.
This
So
from
derivative
YouTube says
u.
try-
Use the double angle formula. What? Yeah, b is just a constant. Let's try this way.
Sine
I want to try
squared
this way.
That's
If this doesn't work, then I will try the double angle. Let's say the dv is equal to e to the negative ax dx. When I integrate that, I'm gonna get I think negative 1 over a e to the negative ax, right? I believe that's right. Okay, so then let's write out what we got as our integral. I may need the double one. Okay, so this is going to equal to uv. So that's going to be sine squared bx e to the negative ax, and then all over negative a. Okay, we'll try that, Don. That's probably, yeah, because sine squared is, 1 over 2 cosine squared. But I'm just going to show like what my gut instinct would have been. And why I might be wrong. It happens. Sine squared e to the negative ax, negative 1 over a, cool. Minus the integral of v to u, so that's going to be plus the integral of 2b sine bx cosine bx all over a, and then this is e to the negative ax. I'm kind of interested if you can do that, though. Yeah, exactly. I think this may be another trig identity. One sec. Let me come up with this. So let me see. Trig identities for, and I think it will be the double. I think the double angle one will come up here. Yeah, it'll probably come up from here. You know, you can use Euler's identity. I could. You're right. I could have written this out as what? E to the ix minus e to the minus ix all over 2i. And then gone all the way through there. Yeah. But then this would be squared. Oh, this just becomes a mess. Yeah. I think Desmond's on the right track here. But I want to see if it comes out later here anyways. Because... yeah, do you see how that double identity is just going to come up right here anyways? So now I have 2 sine bx cosine bx. That's the same thing as sine of 2 bx. Which then that's one of then you'd have to do that 2 more times, I think. You need it to oscillate, right? Until you get your original thing, and then you can like bring it back. Okay. So you could do this. This is going to be another like 3 or 4 steps. Because what I could do is I can convert this into the integral of... that's going to be b sine of bx all over a e to the negative ax. And this right here, I mean, this is a good exercise. All right, there's a 2 here, sorry. Yeah, 2 sine theta cosine theta is equal to b sine 2 theta. Okay. Within here, this is its own cool little thing. Yeah. So here, and I'll do it because this is a cool thing to look at. Yeah. So watch. Dun, dun.
To be or not to be.
To be or not to be, yeah, right.
You didn't have the 2 bat in, I guess.
I did. Well, yeah, one second. I gotta change this. I need this to stop. Okay.
I mean, like 2b sine 2b of that.
No. Because for the identity here, Seth, 2 sine theta cosine theta is sine of 2 theta. So I need 2 sine theta cosine theta to give me sine of 2 theta. Right? And then I have b over a, and then I have this. So, okay, here, let's pull the b over a out. So I'm going to say this is the integral of b over a, and we're going to say sine 2bx e to the negative ax. All right? What I'm going to do is I'm going to pick, and then this is also dx for all this. I ended up at the same identity. I do. Yeah, it's kind of funny. Yeah. If I choose u to equal to sine of 2bx, then du is equal to 2b cosine of 2bx, right? And then dv is equal to e to the negative ax dx. So v is equal to negative 1 over a e to the negative ax. Okay. So this becomes uv. So that's going to be sine 2x. This negative 1 over a e to the negative ax. And then it's going to be minus v du. So that's going to be plus the integral of this. Watch. 2b cosine of x. And then this. Okay. Now here's the cool thing here. Is I'm going to come back here. And I'm going to say that now my new u is equal to cosine of 2bx. So du is equal to negative 2b sine of 2bx. And then here, let's pull this stuff out. Pull this stuff out. 1 sec. This is all going to go over here at some point. And now I say that dv is equal to e to the negative ax dx. So v is equal to negative 1 over a e to the negative ax. And now, so that's going to be plus, so plus this. When the fuck will anyone ever use this in real life? Probably not, honestly. This is, I mean, it's cool. It's a cool concept here. Because this shows how, like, with integration by parts, you can get looping to happen. Because this is going to be uv. And then minus, so we got minus, so this will actually do something. So watch this. Minus the integral, and then it's v du. This is the cool part. I'm going to show you. So, pulling this out, right? Let's just pull this out. Let's say minus 2b over a. Okay. The cool thing here is that this thing right here is the same as what we started with. You don't really use math in real life. It's more of a hobby. All the cool math is useless outside of a blackboard. I thought hobby was supposed to be... I think this is fun. Because look, I eventually said that this... Right? So we said that the integral of all of this was equal to this. right? Plus all of this. So that's this. And this thing right here is the same thing as this thing. So you can move this thing all the way over if you want. And then, yeah, one sec. And then there's a big B over A outside of everything. I mean, this is more or less tedious is what this is. You're okay. Okay. So if I move this over to here, I'm going to get that 1 plus 2b over a, and then integral of all this is equal to this. Yeah. Okay, cool. So then you just divide by 1 over 2b plus 2b over a.
Yeah, parentheses.
Parentheses. Yeah. Well, what? All this? What are we talking about? What parentheses are we missing?
Yeah. 1 plus 2b over a. So 2b over a times the integral is 1 plus that 2.
Oh, yeah. Sorry. Yeah, that's what I meant. Sorry. Yeah, you're right. Good. Okay. So, I mean, this is a huge fucking mess. So, it was...
Right now it's 2b over a times the integral of... Yep. And
then
that
it's all
integral plus
this.
1. All that plus 1 is that.
Wait, and then I feel like all of this was also multiplied by b over a. Yeah. Christ. Okay, so this is just an absolute mess. Okay, so one sec. So it's this times b over a. And then it's this plus that. And then this is all like evaluated, I feel like, between, what was it, 0 and infinity for x.
Yep.
Dude, why? Okay. Is this like not defined? Because the issue is that like you can't really do sine of infinity. So yeah, I'm a little lost at words like what the answer here is supposed to be. I know it when it's 0. Right, when it's 0, this goes away. And this becomes 1. What were they asking for actually, by the way? They just said like figure out the integral.
It doesn't say. It just says it just gives you the integral with.
Oh, okay, well then whatever. Then like fuck, this is the answer. Like enjoy. Yeah. Anyways, okay, cool.
That's dope.
That's an interesting question
the
there.
limit problem, then, right? I believe.
Yeah. Let's do one of the limit problems. Well, actually, let me help out
the
like
one
some
limit
of
problem that we're supposed to do, which is number 21 on that sheet.
Yes, let's do it. 21. Let me go find it. It was in here from Zimfonky. Let me grab this. All right, one sec. Clear. Oh, it says, okay, this is very, very blurry, but I'll try. Given b is finite and a is greater than 0, determine the values of a and b such that b is equal to the limit as x approaches 0 of a minus the square root of a squared minus x squared over 4, all over x to the 4th. Default says user says, hey man, just found this and it looks interesting. One thing is I'm in 7th grade and I love math. According to test scores, I'm at 11th, 12th grade level. With that being said, could you explain an integral? Yeah. Integral is... we should get him to read that paper from the doctor who described integration. But an integral is really just the area underneath a curve, is what it is.
where a derivative finds a slope, an integral finds the function for that
Right.
slope.
Exactly. Seth has it right. Yeah. So if you have like some function here, like f of x, and you have like some x point A that's starting here and some x point B that's finishing, then the integral of f of x dx is just all this. Sorry, let me show you. Sorry, set this. Yeah. So again, yeah. Sorry. If you have some function, f of x, this graph right here, and you want to figure out a starting point A and an ending point B, and then the area underneath the curve from A to B, that's equal to the integral of f of x dx, and that's from A to B. That's what they are in concept. I mean, that's the concept of them. How to do them is a whole course, and it's just all the different fun strategies and tricks you can do. Maximizing ketchup in a paper cup. That's a good one. Questions we already know the answer to are my forte. Yeah, I love that. Okay, let me see if we can do this one, though. Given B is finite and A is greater than 0, determine the values. Okay. I mean, I'm tempted to use L'Hopital's rule, right? Should I use L'Hopital's? You think so?
Here, you want a clue? You want the big clue?
Yeah, give me the big clue.
Note problem 19 in that sheet. You want that?
Note problem 19. Okay, well, I gotta go look at that.
Yeah, in that problem set. Evaluate
Yeah.
the following limits using L'Hopital's rule.
Okay.
A whole 15 of them on that topic. So there's
What's a default?
probably a good
Yeah,
idea
yeah.
that it's probably having that in some way.
All right, I'll go look at it. Yeah, default user. Yeah, for sure, man. Yeah, you learn linear
It
algebra
probably
because you
uses
got
it in
bored
some way,
once.
'cause it's-
Okay, one second. Let me go find that. Yeah, linear algebra is cool. It's very useful for coding and any sort of computer stuff. All computers are matrices and linear algebra.
I'm not meaning you to copy it or anything. I'm just saying note that problem. It's like there's 15 of them as you use that rule. So
Okay.
most likely this one uses it as
Okay,
well.
yeah, let's use L'Hopital's rule on this one. Let's just do it. Okay. So, L'Hopital's rule I'm allowed to use if I get like infinity over infinity or 0 over 0. AI is basically just linear algebra, correct? Yes, yeah. AI is basically just linear algebra. I agree with that. Okay. If I plug in 0 for this goes away, right? This goes away. So I get 0 over 0, which is like one of the cases cool. This is why it's okay to use L'Hopital's rule.
It's an A minus. A
There's
squared
actually kind of a cheating way to do this. We could
There
also
is
just
0.
divide. Can't we just divide the top and the bottom also by x to the 4th?
Well, you can do whatever you want.
Well, I'm gonna do it.
Divide this by x to the fifth.
I'm
I'm going to.
I'm gonna do it by x to the 4th because I want to see what happens. So this would be 1 over a squared minus x squared, and then this would be over the square root of x to the what is it? X to the x to the 8th, right? Yeah. And then this would be minus x squared over 4x to the 4th. This just like saves you steps in all the derivatives. Yeah. X to the 4th. Thank you. Yeah, Don's completely right. Yeah. Okay. Because watch what happens here. So now I have the limit as x approaches 0 of. So we're gonna have a. So this is gonna go away and be 1, right? So we have a over x to the 4th minus the square root of a squared over x to the 8th minus 1 over x to the 6th.
Yep.
Right? Minus 1 over 4x squared. Okay.
No, on that last one.
No? Why not, Seth?
Minus 1 over 4x squared. Yeah, sorry. I thought you said
Yeah, we're okay.
4x squared.
We're okay,
Whatever.
dude. Okay, cool.
I know one thing I could do on this. But this is one fraction, but that'd be a bad idea because instead of Papa Batch to
The problem is like for L'Hopital's rule, I have to have fraction over fraction. So I kind of messed myself up a little bit. I should have divided it by x to the 3rd. I think is what I should have done.
You can multiply by adds and fits that easily.
You're right. I could.
Easily fits.
Yeah. I think I want to multiply by like x squared. Is what I want to do. I'll show you why.
Oh,
I think
Jeff has a point. Jeff has a point.
The 1 over minus x to the 4th is going to grow the fastest. Yes, correct. This will, well, yes.
And he made the second point.
The others will become zero-ish compared. Well, I feel like this identity is going to become just infinity. I think x squared is what I want to do. Yeah, let's do x squared. Jason Wu agrees with me. He says x squared is smart. Yeah, because I kind of shot myself. I wanted to at least have something on the bottom. So this will become 1/4. This will now become x squared, a squared over x to the 4th, and then this will be 1 over x squared, and then this will be just a over x squared. Okay, cool. And then this is all
a over x squared. Yeah, a over x squared, and then the bottom is now have an x squared.
Now the bottom is now all x squared. Okay, this is cool because top goes to like, I don't know, like infinity, right? Wait, is infinity over 0 okay for L'Hopital's?
Infinity over 0 is the same as.
It's not. It's sometimes different. I think you need 0 over 0 or infinity over infinity.
And it's a node. There's a node confirmed by Zach.
Yeah.
Infinity over 0 is super infinity.
Super infinity. Am I allowed to just say that the limit's infinity? I feel like I am.
Are you allowed that? Because it says. You want a clue? You want a clue? Read the twats.
Oh, it says given b is finite.
There you go.
And a is greater than 0.
B is a solution to this limit. Therefore, it's not infinite. There's a solution.
There is a solution.
But what does it say to do, though? It says find a and b such that this would
such
be
that
true.
Okay. So
which actually would mean that maybe with a's value, it's not known to be infinity.
I can't really think of an a that would make it finite.
So how many days have you spent on this question?
This is a different question. No, a can't be 0. A has to be greater than 0. That's the requirement.
Yep, that's a rule. So.
Okay, one sec. Let me think. I feel like stuff needs to cancel something, almost like completing the square or some shit.
Yeah.
Right?
Huh. A equals 1? Oh, this is different solution. One at a time. Cases. We don't
if
want
a
that.
equals 1, lots of stuff cancels if a equals 1. Let's try it. Yeah, whatever. Fuck it. Let's do it. We ball.
Ooh, I see.
Let's say a equals 1. Test. Testing. So 1 over x squared minus the square root, and then this is 1 minus x to the 4th minus 1 minus x squared, which is the same thing as 1 minus x to the 4 x squared over x to the 4th, right? Right?
Whenever I'm behind, so it is.
Oh, sorry.
Quickly.
Sorry, x squared is what I'm gonna do to get this, and then this is minus 1/4 all over x squared. Okay. So this will be a difference of squares, right? So this will be 1 minus the square root, and so this is going to be 1 plus x, 1 minus x,
so
all over
a's are 1s,
all over x squared minus 1/4, and this is all over x squared. Can I scroll up to the prompt again? Yeah, here, one sec. Zach. That's the prompt.
Ooh, okay, so 1 minus things minus.
So, ooh. Okay. So,
But this is interesting. 1 minus the square root.
Should we keep this
times 1 minus that minus x squared? That's what this turns into, which is all that's.
Well, here let's make this x squared over x squared, right? So I have 1 minus the square root of 1 plus x, 1 minus x, minus x, minus
square root,
minus 1/4 x squared.
Is it?
No. Is all over.
It's not 1 minus. I can't agree with that. I can't agree with that.
No, here's what I'm doing. So I'm combining them. I'm saying x squared, and then I'm putting this as something else over x squared. Nice default. What's up, dude? Yeah. Oh, yeah. Glad you found the Discord one. Not yeah.
What I'm saying is I changed it. It's 4 minus 4 square root of 1 plus x 1 minus x minus.
I'm just like I think I'm just dancing around it because I just really don't want to do L'Hopital's rule, and I think I might just have to do it.
Because you're putting the x squared on the bottom, yeah, but
Yeah.
the problem is that last term. That last term is a 4x squared on bottom.
This is a 4x
We multiply
squared.
everything by 4. So 4 minus 4 square root of 1 plus x 1 minus x minus 1/4 x squared over x to the 4th. That
Yeah.
third term in the numerator has an attached 4.
Has
the
a
x
1/4.
squared. It's
What?
yeah, 4.
Has it? Why does that have a 4?
4th. I'm saying there's a 4. It's the denominators are x squared, and 4x squared.
I don't understand.
The denominators of the fractions above are 1 x squared, 4x squared.
Oh. Yeah,
Just
but that's why
putting all
that's
squared,
why
right?
I'm just putting a 1/4 here.
Oh, just doing that to okay. We can deal with the fraction. We don't need a fraction there. We just multiply the number by 4.
Yeah, we just multiply everything top and bottom by 4, but I don't see that fixing anything. What's up, boss man? I'm getting mind fucked by some math right now. Okay, this is a tricky one. Do we just want to do L'Hopital's rule? I think I might just do L'Hopital's rule at this point, just because
that's the truth. If it's 1, if A is 1.
Let's just do L'Hopital's rule. I'm just doing it. So I'm gonna do DDX. I enjoy this because I'm around like-minded people. Most people. Oh.
And if we put 0, we hit the problem again. Oh, whoops. Okay.
Wait, 1 sec. Sorry, that's an alarm. 1 sec. Bro, I'm a 9th grade student from India. And I was having some problem with polynomials rational root theorem. Yeah, cool. Submit a screenshot, and we'll go over them. That's the best way for us to help you, is what we say. We'll help you that way. Dun, dun.
It was like the one that that you copied early in the stream is not in there anymore.
How do you do that? You go to the website down there. It says actualdiscord.com/submit. That's the easiest way to do it.
It looks like the one problem that you had is not in there. That you copied out is not in there anymore.
Oh, right. It disappeared? Why?
Must have been taken out.
Oh, I don't know why it does.
Maybe because he didn't need us anymore for it or something.
I don't know. Okay. Let me just do this. DDX of the top. I'm going to do DDX of the bottom. Okay. So, derivative of the top. That's going to be 1/2 a squared minus x squared to the negative 1/2 times negative 2x, right? And then we're going to say minus x over 2. And then the bottom is going to be 4x to the third. I still have 0 over 0. So we got to take another derivative. Okay.
Derivatives till when? Then.
Until we get something that isn't 0 over 0. The issue is like, bro, this is going to fucking blow. Like, because first of all, I'm going to have to take quite a few more derivatives.
Oh no, this is a nightmare.
I have to
product rule.
Exactly.
Just keep doing product rules.
Unless, 1 sec.
In 3,
28 points left.
So in 4 derivatives is gonna do.
Yeah, I don't want to do that.
What
What if I just divide by x to the third? What if I divide by x to the third? And then I only have to do one derivative on the bottom. Let's try that.
Well, if we do that, then you have to do product. You have to do quotient rule
Yeah.
above, as well as product rule. That's
We are
your
definitely
that's your scenario there.
It's okay. Let's just do it. All right. So I'm going to divide the top by x to the third and the bottom. And we're going to just do this.
Then why don't we do it at the beginning before we even?
That's what I'm doing. That's what I'm doing. So I get
doing
a
x
over. a over x. I'm gonna keep everything in positive exponents or whatever, not fractional exponents. X to the third, and then this is gonna be minus x, and then that's going to be square root of a squared over x to the fourth minus 1 over x squared.
Yeah, we would also have to account and hope
Minus.
that the top doesn't do 0, 0 either.
Oh, it doesn't
Right.
actually either. Yeah, the issue is that this is gonna fuck things up. Okay, so yeah, whoever told me earlier, yeah. Damn, dude, this one
Hopefully the top
sucks.
doesn't-
You gotta get in the hospital now.
I'm just putting all
Obviously,
the.
don't
I
go
just
and do that.
Dude, what?
We can't condone anything of the sort.
Okay, I'm taking a break. One second.
The top is probably gonna do it as well, and it's gonna do 0, 0 again.
Oh my god.
That has something to do with,
All right.
and then it resets.
I'm sending this to ChatGPT. I'm sending it to ChatGPT.
Yep, that's what I was.
I'm sending this to
was
ChatGPT.
expecting.
Sending it.
That would. Ugh.
We're gonna go kill some dolphins and have ChatGPT burn a bunch of electricity and water to do this. Why can't y'all just give me nice, easy questions like middle school, high school? This is fucking nightmare stuff, dude.
I put some nice ones in there, and then
I appreciate yours.
Sanders put an annoying nice one in there.
No, but that's still kind of nice. Yeah.
Yeah, I know. Mine's are nice. I pulled it from a couple videos. I like that you will
ChatGPT
like
wants to
'em.
tailor expand. Oh man, dude, this is so out of my wheelhouse. I mean, I
Good.
can do a tailor expansion, but why? Get the fuck out of here, dude.
Would you rather just ask it to see if it's find a different way? Ask
It's very easy apparently once you do that though.
ask it to do a different way then, and see if it will.
Yeah, no. It says you can do it with repeated L'Hopital's rules.
Okay.
Yeah.
Are you gonna
So
show
watch.
it?
That's
You're
what
gonna
I'm
show
gonna
it?
show it. I'm just gonna show the solution. It's actually pretty cool. So, yeah. And then here, let me get the original question back. No, come
Oh, you're
on.
gonna failed. Let's
No,
see.
that's not it. One sec.
Expand the square root. Oh, okay.
One sec. There we go. Okay. So yeah, the key thing is yeah, expanding this. This thing like really sucked. So what they did is they expanded this out. They expanded this out with Taylor series, which isn't the worst thing in the world. And this goes. They're stopping at order x to the 6th. Technically, it keeps going more and more and more. Okay. So then they show that the numerator. So all of this, once you take into account this part for the Taylor expansion, and with this, you end up getting this. Because now you can combine like the x squared term with this x squared term. We're still doing the question. I'm just showing. So apparently the solution to this was to use a Taylor expansion for this, which is a fancy way of writing out irrational functions like square roots as a bunch of polynomials. So now we have this. Okay, and then they say force the x squared term to disappear. So for finiteness, that's an interesting realization. We need the x squared term to disappear. Oh, you know why, Seth? Because we have an x to the 4th on the bottom. So in order to get this thing to go away so that we're just dealing with x to the 4th over x to the 4th, I set this equal to 0. And so I say a equals to 2. Now once I do that...
And also, speaking
Yeah.
of, what was that put in chat? A equals 2 is an interesting case.
It is
Before
an
you read
interesting
that.
case. Yes, thank you, Zach.
So there's... Yeah, by normal series, okay.
So now you get to this, and it's this, right, over x to the 4th. So now you
64,
just get
okay.
1 over 64 order x squared.
And,
And
and then
and
B,
as x goes to 0, right, x squared terms go away.
and what's our A and B then? So
Our
A
B
is
is
2
1
and B is...
b is 1 over 64. That's pretty fucking cool.
Now,
Yes.
now, could we do this without needing...
Yes,
knowing that A
we
equals
could have
2,
done it with
without doing-
with repeated L'Hopital's rules, which again is what I looked at, and then I just eventually said like I'm not doing it because this is just doing one derivative. I would then have to do a bunch more. I'd have to do 3 more of these for this to work. And this is like product rules and power rules and chain rules. And yeah, it's a huge pain in the ass. But okay, cool question.
It's kind of funny. It's kind of funny for one reason. We chose A equals 1.
Yeah, we should have chosen a equals 2.
We should have chosen. We
We messed up. We messed up, boys. We messed up. It happens. It's okay.
Ready. Let me see if the other person put it. Oh, there's the problem.
Yeah.
Ooh, a dash put one in there too.
Adarsh put one there too? Here, let's do Shantrix's. Shantrix has
Yeah.
been waiting around and chilling. Let me do Shantrix's.
A dash is nice and easy.
I know. Adarsh's is super nice.
For
and
the
easy,
love of
but-
God, give me easy questions. This is
I
just
know.
hurting my brain.
Yeah, I know that these are hurting my brain, but this one should actually be better, I think, because Adarsh gave us Shantrix gave us question 22, which isn't so bad.
A cylinder is radius 12 and height 30. The
Mhm.
top circular face of the cylinder is the base of a tone, and the center of the bottom circular base of the cylinder is the vertex of the tone.
Yeah.
The sphere is placed inside so that it touches the tone. The base of the cylinder and the side of the cylinder are shown.
Mhm.
Which of the following is closest to the radius of the sphere?
Cool. This isn't too bad. So this radius here, I think we're gonna do things with similar triangles. So if this is 12.
So let's start with some labeling, because I know
Yep.
some labeling here.
Yeah, we're gonna do some labeling.
I know that if the bottom's radius 12, then the tone also has a radius of 12, of course.
Yes. Which also tells me... No, it doesn't tell me anything yet. Okay, so I just need to know the radius of this.
The height of the
I just need to know the radius of
tone
this,
and
right?
The cylinder is 30.
I already know what Jeff is going to want to do. Jeff's going to be like, make it a coordinate system. He's going to like, yo, call this like 0, 0, and then just do everything else.
And I also know how much space that sphere has to fit into.
Darn.
I know how much space that sphere has to fit into.
How do you know that?
You want to do it?
Oh,
Just
yeah,
easily?
sure.
Find the, what is the formula for volume of cylinder?
Volume of a cylinder, 1/3 pi r
What is the
squared
volume
h.
what is the volume of a tone? Solve both of those,
Yeah.
because you know both of them.
Wait. I don't even think we need to use volumes here, dog. I think we can literally just use
So
this.
I'm saying, you asked me a question, I answered that.
Oh, it's okay.
I said,
Well,
I know how much space that sphere has to fit into.
oh, I agree. I know you know that, but yeah, okay. But in terms of
That's how, so
in terms of solving the question though, Seth, I just want the radius of the sphere. So this
I
is
know
a
what I'm
2D
saying. That
problem.
would give us the kind of
we
it,
don't
but
we don't need it though. Watch this. This is pretty cool. So if I know that this height is 30, Seth, then I know that, for instance, this triangle that's formed, let's say from like here to here, right? This has a height of 30 minus r, right? Do we agree with
and
that?
minus
If
r
this
comes from
r is the radius of the sphere,
that triangle.
right?
I'm behind, remember?
You're okay. Let me see if I can start streaming on Discord. It should be okay now. One second. Let me just do it. Y'all tell me on Twitch if it starts fucking up again. I'm gonna go yell at my internet provider.
Oh wow, we have 2 more now.
Okay.
And they're both not smacked. Okay.
Okay, so if that's like this, right, then this whole thing here is 2r, right? Okay, so you can actually just solve for it this way. So by similar triangles, right? So 2r over 30 minus r has to be equal to whatever this length is, which is 12
Well,
over 30. Be careful, because the bottom right corner of that triangle isn't on the sphere. That's okay.
he's being very sneaky and making sure you
Yeah,
mess this
I'm just
up.
saying that we have like 2 triangles here, right?
But what Fembots is saying is that sphere, that triangle is not on there. That's not only that radius. There's a little bit that's not.
The bottom right
Which is gonna mess your
corner.
plan up.
Wait, sorry. The
The
bottom right corner of
that triangle isn't on the sphere.
Oh,
Therefore, it's not going to work.
oh fuck.
As simple. But I don't care.
Man, I thought I had
You know
something
why?
here.
It doesn't matter. You know why?
Why?
Read the Twetson.
Oh, which is closest? Yeah, but this is gonna this is gonna
approximated
fuck with
one,
us though, dude.
Which
But
means
it's up.
I don't care.
They're off by
Which means we may
0.1.
not care.
They're off by like 0.1 though.
Well, yeah, but I'm saying we might not care. I don't know what is it going to give us before we worry about
Okay,
it.
yeah, let's just do it, right? Yeah, let's just do it.
I just want to know. I just want to know because we might.
All right, let's
we
make
might
let's
not
make
need to
the
worry about it.
let's
We're
make
not
the poor
close.
assumption here. We're making poor decisions and assumptions, but whatever. Let's just try it. 30 minus r over 2r is equal to
Over 30. You said
30
12
over
30.
12.
All right, you did it. Did I?
Yeah, 30 over 12, right?
Yep.
Yeah. Default says what program do you use? I use Group World.
I'm gonna do
It's called
this
Group World.
easier way here. 30
Oh.
minus R is to be
Well, so it's
180R.
360 minus 12R is equal to 60R.
That's really the easier way. 12 times. Nope, that's not gonna work. Nope. Don't worry about it.
What's wrong with this, dude? What's wrong?
No, I'm saying what I was saying don't work.
Oh,
Don't worry.
okay. Just divide by 72. Divide by 72.
And then
What's 360 over
It
72?
says me 5. So
Oh, it's just 5.
that's not gonna work.
Oh, see, that's why it doesn't work.
You done messed up,
Aw,
That is A, but I
fuck.
don't believe it's gonna be A.
God damn it.
I don't feel like that's
What
gonna be
the
close enough to
fuck
work.
is this piece of shit?
Yep, definitely not.
God damn it.
So
It's not going
there's
to
the
work.
proof- there's our
All
proof of
right.
contradiction.
All right. We got to do more work. All right. My
There's
quick
the,
and dirty
there's the
way
proof
didn't work.
contradiction. Where it wasn't
Man, I
work.
wanted to use geometry. What's up, Caitlin? Invisio.
I know it'd be easy. That's why I contradicted.
It'd be
That's
so
why I was hoping
easy.
it's contradict.
Okay. All right. All right. But I do know. Okay. Do I have to like go make some other triangles here? I do know that. Thank you, Femvox, for that realization. It wouldn't be question two.
Oh yeah,
Dude,
that's fine, Chandra. It wouldn't be twice in 22 if it was that easy.
Okay. Well, I will say that this connects to this, and this must be perpendicular, right? Do we agree with that? Right?
Can we agree that it tries that triangle line though?
Well, it's not going to connect to this, but here, one sec, whatever. There we go. Okay.
Does it connect
We-
to that?
That will be perpendicular for sure.
what?
At the point.
By what?
Like at the. I don't know what you mean by what, dude. What?
I mean, what rule? Well, what tells you it's gonna touch there?
Oh, I don't know, like tangent circle-y rule with radii and stuff. Oh man, one sec.
I'm just
Okay.
trying to make sure we don't have another contradiction. We don't.
No, I
another
think we're
contradiction.
safe. I think we're safe. I think we're safe. I think we're safe. Okay. I know this is R, but I don't know where this connects. Oh, but I know this is R. Oh, okay, so I can actually figure out this. Oh, but then I need like an angle here. Is this angle related to something? It's like
We don't need an
theta.
angle though. Do we?
Circle at the origin with radius r, intersection with the line with the x-intercept r, and the slope is negative 30 over 12. Circle the origin with radius r. Use the arctan, Luke. Yeah, sure, but do I know this? I know this is theta. Oh, well, wait, one sec. Okay, I think he has a point here. Sorry. So this difference to here, right? So
I do stay away. I think.
One sec. So one sec. Tangent of theta
Oh,
is equal to
maybe.
this arctangent of 12 over 30. What, you want me to get this angle? Which, I guess is the same as this angle. How's that going to help?
Let me show you what see what I saw. We could draw out the triangle as we did before almost, because we know it's a right triangle. So we also know we have R and R.
Well, yeah, I know, but I don't know that this distance is 2r is the issue.
And we know we have that right triangle has sides of R and R. Therefore, the other side follows right triangle. Follows A squared plus B squared equals C squared.
You talking about this one?
No, I mean there's a right triangle. You had a right triangle. Above.
Are we talking
You
about
had a
this
right
one?
triangle
This one I just drew? Or sorry.
Not that. That's not a right triangle anymore. You broke the right triangle when you placed.
This one I drew?
Yeah, that's a right triangle. Therefore, and it has the sides of R and R. The other side
yes.
is
no, but this side is
following the rules
this side is not R. This is R plus like some little like schmidge.
It's R plus hats.
Uh,
We still know the side in terms of R and hats, of course.
yeah, but then I don't know this angle.
We don't need theta if we have a right triangle geometry. If we have a right triangle with,
Yeah,
Because
but
then
then
two sides
but I don't
known.
know. I don't know this distance either.
we don't know it, but we know in terms of R and hats.
Okay. All right, you want to call this x?
R squared plus some r plus x to the power of 2 plus something is r squared.
Okay, so.
And that's something in terms of a squared plus b squared to c squared. Pythagorean theorem?
No, I'm losing you. I'm losing you, dude.
It's Pythagorean theorem right there. R plus x.
There's too many
Power of
unknowns,
2.
though, dude. Right? What? Like, I don't know this, or I don't know this.
Yeah.
So what, you want me to label this as like C as
I
well?
was saying that we do know that in terms of the sides.
In terms of R and X, yeah, I know what C
Yeah.
squared plus R squared is equal to R plus X squared, right?
Yeah.
But now I have two fucking unknowns. I don't know X and I still don't know C. And I don't like
We do know
introducing-
C in terms. We know C in terms of R and S,
Sure.
which is always, which gives us the right, which gives us the triangle. So yeah,
What? Which gives us this triangle?
there's a statement that we do know that, not necessarily. It's a
Yeah, but
somewhere.
One sec.
I'm just saying that we know that in terms of everything, if we care.
Okay. 30 minus R over 2R plus
Something.
2R.
Unknown,
Well,
so.
well, I'm gonna say R plus X, right?
Okay.
Has to be equal to 30 over 12, right? But then the issue here is that, like, I don't know X, and you can be like, oh well, I know X in terms of C, but I don't know C either. How am I gonna get C?
Correct. We know C in terms of R and S, which is annoying.
Yeah, that's annoying. That doesn't help me. Yeah.
Oh, we do. We do know that's. Ha, we do. Lovely. I think at least if I'm doing this right. See, we know that we know this. We know C value in terms of R and S. We can solve for S if we need to.
Yeah, but then we introduce a new variable C.
But we know C in terms of R and S.
I think we just keep you're going in circles. You just keep like introducing new variables and then like solving for them, but then like they're in terms of each other again.
Yep. That's a loop.
Okay, give me a
That's a
sec.
loop.
All right, let's clear. I need to clear my head. Clear my head. I have not gotten a fucking break this whole stream of like an easy question.
Yeah, that's fine. Pushing through 'em. We've done the hard ones. You did a physics one on Tumming, so
I would love a physics question, honestly.
there's a physics and a chemistry in Tumming. So once we do,
Let me see. Let me see.
got
I might just trash this one for now, just because I want to help. I want to do something that I know how to do.
Oh, there's a hint. There's a hint, by the way.
Ooh, Invisio's got a question. I'm doing this one. All right, we're coming
There's a
back to
hint, by
this.
the way, for Sandtrans one.
What is Shantrix's hint? Yeah.
Posted right there for you to see it.
Okay. All right. One sec. Yeah, he is right.
Yeah, you
I
know,
was noticing that here. I was noticing that like this is whatever. This is going to be 90 degrees, right? And then this is also going to be 90 degrees. So then this is
There's
like
two right triangles, yeah.
this is a fucking bisector is what this is. And then you know this is R, you know this is R. If this is R and this is R, and I know this is 30 minus R, am I allowed to say that this is also 30 minus R? Am I allowed to say this bisects it? I guess it does, because they cover the same length. Right? So what, this is also 30 minus R? How does that help
Go
me?
ahead and try it. Go ahead and try it and see if it's done it is.
Okay, I'm gonna just say that this is half the angle. Okay, I see where the arctan's coming from. One sec. I think this is easy. Okay.
Oh, by the way, Jeff has proven you wrong.
Whatever. I don't give a fuck. All right. So
Vocabulary
this is
wise,
theta.
it's median.
Theta is equal to the arctangent of 30 minus 12, or 30 over 12, right? Opposite or adjacent. I need my calculator.
So 15 over 6, so 5 over 2.
One sec. I need my calculator. Oh, 30 over 12?
Arcane of 5 over 2.
Is it 5 over 2? Oh, it is.
No, I said
Oh.
arcane of 5 over 2.
Oh, okay. Oh, but that's not
That's
anything I know.
simplified for you.
That's not anything I know easily, is it?
Yeah, it is. 30 over 12 is 5 over 2.
No, but I don't know what the arctan of 5 over 2 is.
I know you can put that in chat later.
Oh, okay, let me put it in the camera. Okay, so 1 sec.
I've-
Arc tangent
always
of 5
combine
over
it.
2. I agree
I
with this.
simplified it. Oh, I did.
Okay, cool. 68,
I did. And no matter now.
68.20 degrees is that. So then we do 90 minus that. So 90 minus is that. Oh. So
Error.
90 minus. 90 minus error? 90
Error.
minus that, you dumb. Okay, that. And then we're going to divide that by 2. So 10.9.
There you go.
So I'm going to say that this thing right here
And waiting for it to come to that.
is 10.9 degrees. Okay. Cool. So then this is an angle. This is a right angle. Opposite over adjacent. So I can say that the tangent of 10.9 degrees is equal to 2r over 30 minus r. Right? Okay, cool. So now I just solve. So tangent of that.
Before you solve for R. Before you solve for R. That way you don't have to do as much
I'm just gonna leave it. Okay.
calculator question.
Hey, I'm being lazy at this point. Negative. I'm gonna 0.193 is equal to 2r over 30 minus r. So multiply by 30. So 30 times 0.193 minus 0.193r is equal to 2r. Add that over. So 2 plus 0.193r is equal to 30 times 0.193. And we're going to divide it. Okay, it's that divided by 2 plus that. That gets
Yep,
me an
that's
R
a
of
no.
2.6. Well, that's
Which
not
is
good.
interact. So there's a. But we had hard and half. No, we didn't. Uh-oh. So what
No, we
happened?
didn't. Then we didn't.
Therefore, this is a contradiction. Therefore, we messed up somewhere else. Lovely.
Love that. 1 sec.
And also, Jeff said it was a median, not an angle bisector. And I mentioned that dashed line was a median rather than a angle bisector.
All right, whatever. I'll come to this question later. I'm gonna do the physics one. Everyone, give me tough questions today. Okay, here we go. Let's do this.
Gosh, is easy.
This is great. I love this. Thank you, someone, for giving me an actual like softball of a question. Versus, I've just been getting like beaten up for like the last hour and a half. I feel like I've just been getting abused by math. Oh man. Okay. It says consider a mass hanging. Okay. Assume a thin rope will break when the tension in it T1 reaches 105 newtons and the thin. Okay. Calculate the mass M. Okay. Cool. All right. So whenever I have questions like this, yeah, nothing but fastballs and curves for tonight. Yeah. Mental workout till failure. Yeah. Y'all are testing me. Okay. I like to consider like what the forces are here. That's what we're gonna do. So here, I'm going to have some force pulling down. We're going to call this like T3. Okay. And then we're going to have this, which is T2. And then we're going to have this, which is T1. In Visio, if you see this so far. All right. Good to see you, other end. Okay. I can now break this up into components. So if this is 50 degrees, that means we're going to have some component of this that points in the x direction. So I'm going to call this like T2x. And then we're going to have some component that points in the y direction, which I'm going to call T2y. And then for T1 here, I will also have T1x, and I also have.
And we know some other angles too.
We do know some angles, right? You're right. So this well, that angle's 60 degrees. Oh, so actually, I should draw it this way. Sorry, 1 sec. We're gonna call this T1y, and then we're gonna call this T1x. And then we know that this angle right here is equal to 60 degrees. Okay, cool. All right.
And there's
then
M at the bottom. And there's a mass.
and there is
going
there
on
is
the
a mass. There is a mass right here. Yeah. So that's actually kind of cool. If we consider like the mass here of mass M, this has its own set of forces, which is going to be mg down, and it's going to be
tension pulling back on itself.
yeah T3 pulling back on itself, right? So it's going to be T3 pulling it up, and so these forces
and we
are the
assume
same.
no other forces are present.
We assume everything's at, you know, whatever equilibrium, not moving around and shit. So from
No resistance,
this,
etc.
I know T3 minus mg has to be equal to 0. So that means T3 is equal to mg. So the tension here, T3, which is also pulling this thing down, what I call like the intersection point, that's going to be... Ooh, Caitlin's got a good question with the masses. I like that one. Yeah, that's a really good one. We'll do that one next. That's the same force. Okay, so now what I do is I'm going to do sum of forces in the x direction, and we're going to do sum of forces in the y direction. Okay, so in the x direction, going left, right, I have this pointing to the right. So I have T2x, and then I have this pointing to the left, so minus T1x, and then there's nothing else. And this has to be equal to 0. In the y direction, I got T2y pointing up, and I got T1y pointing up. So I'm going to say, cool, T1y plus T2y. And then I also have T3 pulling down, which I know is also just equal to mg, so I'm just going to say minus mg. And this is also equal to 0. Okay. So
Which means
once
that T1y plus T2y is T3.
Good. Technically, yeah, it's equal to that. I like to just set things equal to 0 here, but you're right. What I'm going to do now is kind of look at like what we're trying to figure out. I'm trying to figure out m at some point. So I need to know what T1 and T2 are. Lag? We have lag already? I don't know. Fuck my internet, dude.
And we're also assuming that the rope by T1 is breaking before the rest.
Well, yeah, so when we do that in physics, we assume that it's exactly at the point that of failure. That's what we think. That's what we assume. Okay. So, I gotta come up with like some expressions of these with angles. So, for this one...
Oh, lad, by the way.
Yeah, I see that. T2x, this is the sine. So I would say T2x is equal to T2 sine of 50 degrees. And then T2y is going to equal to T2 cosine of 50 degrees. And then on this one, T1y is going to equal to T1 sine of 60 degrees. And then T1x is going to equal to T1 cosine of 60 degrees. Okay. So let's start plugging some stuff in. So T2x is, so we have T2 sine of 50 degrees minus T1 cosine of 60 degrees equal to 0. And then here we have T1 sine of 60 plus T2 cosine of 50. And we're going to say this is equal to mg. Okay. I know T1. They tell me what T1 is, right? They say T1 is going to break at 105 newtons. So because I know what T1 is, I always like to just like put like check marks on things. So, and then I know what I don't know. So I know this. Sorry, no. I know T1. I know T1. I know cosine. I know sine. I know what the sine. I know what the cosine is. I don't know the mass,
we know
right?
T1 we know T1 cosine says state.
Good, exactly, yeah. So the only thing that's missing here, right, is this and this.
Actually, it's not missing because I know T2.
Good. So what I can do, we do this a lot in physics. So anytime in physics I have a variable that's missing in one equation, go look at the other equation and see if it's there. And I do, right? Because I can rewrite this as T2 is equal to, moving this over, So that's going to be T1
T1
cosine of 60 degrees.
over sine of 50.
Over the sine of 50 degrees. Exactly.
And then we can plug that in before we even do the solving of this.
Yes, let's do it. Let's do it. So I'm going to take this.
Because I
I'm gonna
like
put,
I like cosine 50 divided by sine 50 for some reason.
I do.
don't
I
know.
do. My spidey senses are tingling. Okay. So once I start, let's plug some things in. So T1 sine of 60 degrees plus all of this stuff
Times cosine of 50, which
times cosine of 50 degrees. We'll get to
feels
that.
like it's going to cancel.
It's gonna simplify into something. Is equal to mg.
Is mg.
Yeah.
And
so
one other thing.
one
other
other
thing
thing-
beforehand.
this
Divide by
right.
g. Nope, divide by g.
Oh, let me do it at the end. Let me do it at the end.
Because we want to do
Um,
m. We want m, not g. Not mg.
I know, but I'll remember to divide. Okay, so this right here, cosine of theta over the sine of theta, that's equal to the cotangent of theta. Okay. So this now gives me, and then I know what T1 is, right?
Yeah.
T1 was 109. Yeah, exactly, Jeff.
No.
Good.
I'll fill out that. Alright. The last byte. Yeah.
It's okay.
I
So
didn't see the number. So
109 sine of 60 degrees plus 109 cosine of 60 degrees cotangent of 50 degrees is equal to
divide by
mg.
g.
And then yes, I will take
Divided by-
all of this. We will divide by g, and then we should get the mass.
and g
So
is
let's
9.81. And g is
so let's-
9.81.
yeah, let's get our calculators. So one sec, where's my gold calculator? There it is.
And
Okay,
g
so-
can be changed to 9.81.
Yes. 109 sine of 60 plus 109 cosine of 60 cotangent. You don't have cotangent on the fucking calculator. So you have to do 1
So you
divided
write
by
it as
tangent.
cosine
Oh,
of
that's
sine.
so annoying. God damn it. That's so
And it's sine.
annoying.
It's not bad.
As long as I don't fuck up. Okay, 50. Cool. Yeah, it's good. All of that. And then we divide this by 9.8. And so you should get a mass of 14.3 kilograms. That's right. M should equal to 14.3 kilograms.
And what does the Twatson add seem to find? Because we want to make sure we're answering the Twatson before we checked.
Yeah. It says calculate the mass M. So it should be 14.3.
No, it says that the maximum mass.
That is the maximum
Which
mass.
is
It is. So what happens is, like, if the mass was any bigger, then the tension in T1 would have to be bigger. It's 105, not 109. Oh, it's 105. Ugh, god damn it.
So now you can do it again.
Do I gotta do it all over again?
Invalidated.
Well, no, because the
No,
109.
it's
No,
one
I'm
number
gonna
change.
cheat.
One
I'm
number
gonna cheat. Yeah, I'm gonna cheat. So this was with it being 109. So if I want it with 105, I'm just gonna multiply by 105 over 109. Do you see how there's a 109 in every single term?
Nice.
Yeah. So I'm just
That
gonna
works.
multiply by 105 over 109. So here, multiply by 105. This shouldn't change the number honestly too much. Okay. Oh, it actually does actually. Sorry, 13.77. Okay,
Kilograms.
that's it. Okay.
Okay, now we're.
Pardon my
You
French.
see, we didn't answer Twatson because we didn't do the right numbers.
Yeah, I fucked up. Okay, good job. Nice.
Oh, that's easy enough.
Okay.
Nice. With that.
Default
you wanna
user.
do-
Yeah, let me do defaults real quick, and then I'm gonna do that other physics question that Caitlin
and
asked.
then,
And then I'll go through and I'll do all the other ones
I gotcha.
because I'll feel better about myself.
We can do chambers. We can
You're
do
welcome,
the
Invisio.
chemistry one first. We
Yeah.
can do the
Invisio-
chemistry one before we move. Before
Yeah.
we leave science. So that'd be a good one to get out of the way.
One sec. Let me post this one on the campus wire for these kids. Because here, it's because I know this is one of my UCLA students. Let me see. Was this question 12? Okay, we put that on campus wire real quick for them.
Are you putting it on your Canvas page for something?
Yeah, this is my like.
reason?
Look at all these, because their exam is on Friday, dude. They're all asking tons of questions.
Disqualified.
Oh shit. Kudu homework question 12. Adarsh, I will do yours. Just give me a second. Sorry. Wait, not this. Damn it. What?
Oh, what? That's wrong. That's not gonna help them at all. That's math.
That's not gonna help. Here, let me upload. 1 second. Let me get it. I just downloaded it.
Yeah.
Here's
Even
the
that
right.
problem, that's plenty easy.
Yeah. 1 sec. 1 sec.
Here's a W.
Here's the write out. We'll post the recording later. Post everyone. There we go. Oh, I gotta select a category. They're all gonna think this is like on their test or something. The second I post something, they're just like, "Oh, dude, that's gotta be on the test." One sec, we got a bunch of people. There you are, sensation. Yay! Okay.
Hi, everybody.
Hi, everybody. All right.
Go
here-
ahead.
What's up, Ethan? I'm a little bit busy, so just give me a second. UCLA physics teacher, love, yay. Okay, here, let me help out. What was it? Was it unknown user? What's your name, dog? Default user, cool.
Yeah.
Cause yeah, he did find us from YouTube. So he says something really easy, but my dumbass can't figure it out. Oh, that's fine, dude. And then we're gonna do the pulley question for one of my other students, and then I swear I will get to everyone today. Well, we'll actually, yeah,
You will?
yeah.
You're gonna stay over? You're gonna stay
Yeah,
over?
I'll stay over. It's fine. Okay.
Okay. That's
So
good.
to do this, we need to isolate for x. And the way I like to solve for x is I always look at like what is happening furthest away from it and then work my way back, and I always do opposite operations. So looking at
Now,
the
what we
x
could
here.
do-
Well, here, let me
there's
explain my
really
chart real
two
quick.
ways I see this happen.
Yeah. I see x and I see what's furthest away from it.
Either
well,
way, one, we
it's the -6.
multiply, we distribute. We can either
Yeah.
we either distribute this or we divide and be nice about it.
Yeah, I like to work outside in instead of distributing, because I don't know. You'll see. Things are easier.
I know,
-6
I
is
know, I'm
furthest
saying we
away
can
from
do that.
this.
I was saying, I was mentioning what I told it. What we know is the two ways. We can distribute
yeah.
this, or we can
Yes, you could.
solve this as
But
easier. We
A lot of times you
So
won't you won't be able to distribute like nicely. Like for instance, this could be like x to the third or some fucking shit. And then you gotta
That's
like
easy.
expand all this. Yeah, but trinomials. I don't
oh,
want
the
to do this.
theory on there. Okay. 'cause
Yeah.
You have to remember. How to
I'll
read
show
it.
you. There's a method to my madness here. So -6 is furthest away from the x. The opposite of minusing is plussing. So I'm gonna +6 on both sides. So now what that's gonna give me is -130 is equal to -10 times
Oh yes.
x plus 3. Okay.
Dr. Dole mentioned that.
Mention what? Oh yeah,
What
yeah,
presentations comment?
yeah. Like and subscribe. Yes. Go do it. Helps out our numbers. Love it. Okay.
on YouTube.
So the next thing that is furthest away from the x, I think, is the 10, because the 3 is inside the house with the x here, right?
The 3 is
don't,
trapped.
Don't go back to your x. But if you are stuck inside the house with an x, focus on the things outside first. And so that's the -10 here. Some people might be tempted to be like, wait, aren't we subtracting 10? No. And you're not. This is a -10 multiplying by this. And then the opposite of multiplying, so maybe do this. This will probably help you out. The opposite of multiplying is dividing. So I'm going to divide both sides by -10.
If you subtracted 10, you'll be subtracted 10 again, and you'll be getting back to where you started.
Yeah, you'll be in a really bad place. Yeah, you'd be like, oh no. Oh no. Okay, the
Ooh.
next step,
Ooh,
the,
I like that.
instead of distributing, we have -6, so the rest is 130. A can't. Yeah, okay. Yeah, you could do that too.
What? Yeah, you like that?
Yeah, descendant fonts. That's a decent trick. Okay.
Yeah.
But also just do this. -3. The last thing, right? You're adding 3, subtract 3, subtract 3. You get x is equal to 10.
That's
Cool.
X is therefore 10.
My man.
Yeah.
Okay, now
That's
now if we had cubes on there, it'd be a cube root issue, which would be
Yeah.
extra. Yeah.
Cubiting's not bad. So he says instead of distributing, we have -6, so the rest is -130. There is a 0. Wait, why is there
There's
a
an
0?
negative
son?
cancel and a zero cancel.
Oh.
Would like
Yeah.
you cancel zeros.
Yes,
That's what
yes,
you,
exactly.
tends to tell you.
Exactly. And that's what we did. That is what we did. Okay, cool. Perfect. Cool. Okay.
Okay.
Let me do this one
I'll
from Caitlin.
that.
Let me do Caitlin's question here. This is actually a very interesting one.
And then equities too, because equities is science and it's
Okay.
chemistry. That's your job. That's your area.
I'll get through them. I'll get through them today. We're busy today, but we'll do it. Also, like, there was like some cool grant they were doing in California. They're trying to like, give away like free e-bikes, but I think they
and
like
you don't
their
have to worry
website
about
fucked
mine.
up.
That's just something that you might like.
Yeah.
They're easy kind of ones, but they're interesting.
Okay. Let me see.
I'll end with those because I want to show. I want to change something and see what we can do with it.
Okay. Okay. So masses are hung on a light string to an ideal massless pulley as shown in the diagram. The total mass hanging from the left string is equal to the mass of the right string. At time t equals 0, the 0.2 kilograms of mass is moved to the left side to the right side. How far does each mass move in 1 second? This is a great question. Okay. So originally, this has a total mass of 1 kilogram, and this has a mass of 1 kilogram, so they're equal.
Yeah.
Right. And so if they're even, they're balanced, right? And so nothing's going to move. Right? No movement. Okay. Now they say things change though, right? Which is that I take part of this thing, I take 0.2 kilograms of this mass, and I throw it on this. And now we want to ask...
Even if I change 0.1, it'd be to change happens.
Correct. Yeah. If any sort of the mass changes, then this is going to move. Yeah. Yeah.
So the first thing I would do is just
I like drawing
draw
force
the arrows
diagrams.
as change.
Yeah, I like drawing some force diagrams.
I would on the photos just draw the arrows to represent it's doing around the loop.
Exactly, and that's another good thing to do. Yeah, you bring up a good point here, which is, and I tell students to do this all the time, is like draw a big arrow for like where things are going. So things are going this way, right? Because this one's heavier than this. Don't things fall at the same rate regardless of mass? Not with pulleys. I'll show you why. It has to do with the tension. You are correct. If there was no connection here, then yes, everything would fall at negative 9.8 meters per second squared. The issue is that gravity is pushing this down, and it's also pushing this down. So like gravity's like fighting itself. And so if gravity fights itself, like now the mass does matter, because it's like how much fight is gravity doing against itself? It's like Fight Club. Gravity's going to Fight Club. So I'm gonna draw this arrow. So I'm gonna say that in this direction, this is what I call like positive acceleration, and this is what I would consider negative acceleration. So looking here, right, that means going this way is up and going this way is down. The first rule of Fight Club is, yeah. And then for this one, going this direction is up, is positive, and going this direction is down, yeah.
Normally 10 minutes. But
what time do I normally start? Yeah, I normally stop streaming. Yeah, so if you guys want to know when we stream all the time, here, I'll get it for you real quick. Yes, you can set a problem. Send it in. This is our schedule, which comes up, which shows usually we would have ended in 10 minutes, but I'm going to keep going today because we got a lot of people watching and asking questions. So if you ever want to know when we stream, also we have a bunch of other...
I mean, people are ready, are wanting you. Or
yeah,
you.
People want my knowledge today.
What it means is that you're teaching... If people are watching you, you're teaching something right.
There we go. All right. I like doing things right. That's fun.
You got to be teaching something right.
Okay. So, if this is plus and this is minus, okay, let's draw the forces. So,
yes.
this is the 0.8, and then this is the 1.2 kilogram object. Okay, and on the 0.8,
well,
you have the tension pointing up. Default user says, well, I'm going to eat. Thank you so much. I never thought of going away from the parentheses. Yeah. Learn, yeah. Get away from these things.
Mention eternal as well.
Eternal? Oh, yes, Colonel. Eternal. You can. Yeah, I told him he can ask a question. All right. So tension is pulling up on this one, and then we have the force of gravity pulling this one down, which is mg. So that's 0.8 times g. Okay. Now on this one, on the 1.2.
Someone's went to your physics. Says you got another physics in the web help.
That's cool. I'll do it. Tension's pulling up, and now force of gravity is going to equal to 1.2 g. All right. Okay, so now we need to do the sum of the forces for each one. So let's say this is block A and this is block B. So let's do the sum of the forces for the A block. So this is where the direction matters. Okay. So let's remember on the A block, I defined going this way as up, as positive, and this way as down, as negative. So our sum of forces is going to be positive T minus 0.8 G. And that's going to have to equal to the mass of this thing, which is 0.8, times the acceleration. Okay. For the sum of the forces on block B, okay, now tension points this way, which is negative. So this is going to end up being negative T. And then now gravity points down. But for this block, I said down was positive. And so we're going to say plus 1.2g. And then this is equal to 1.2a. This is a... Jeff's... Yeah, exactly. Yeah, you'll get it. Yeah, so this is a very important concept because tension... First of all, the tension is equal in the two ropes. In the two blocks because it's the same rope. Rope tension is constant for whatever it's connected to.
Well, he's always constant.
Absolutely love this. Nice, dude. Ocean and systems control
Well, he was
engineering.
always constant.
That's a cool thing for like maybe like are you gonna work on oil rigs? That's a dope thing. And then the other important thing here is that tension is positive for this block because it's going to move up. And I'm saying like I think about like as like time progresses. So as time progresses, everything is gonna go this way, right? So that means positive progression for this block is going up. And that's why T is positive here. And then for this block, as time evolves, and this thing makes positive progress in time, it is going to move down. And that's why down for this block, for the 1.2 kilogram block, is positive. And that's why gravity is a positive term when we do our sum of forces here. Okay. So we want to know how far each mass moves in 1 second. So I need the acceleration. And here's the key thing. If I'm looking for the acceleration, and I give a systems equations like this, I'm going to want to add these together. And I'll show you why. If I add this equation to this equation, I have plus t and minus t. Plus t and minus t goes away. Cancel each other out.
Yep.
And then I have minus 0.8g plus 1.2g. That's going to be 0.4g. And then I have all of this is equal to 2a. Okay? So that tells me that the acceleration is equal to 0.2g. If I divide this by 2 on both sides. I decided to get my laptop to keep whopping.
That's dope.
Dedication, dude. He's watching while he eats. Okay.
We now know
Cool.
A's volume.
Good. Well, I don't... Yeah, and now we know A's volume because G is 9.8. So, 0.2 times 9.8.
Wait, 1, yeah.
So what is that?
9.1,
0.49?
yeah.
0.49, I think? Or no, I'm fucking up, sorry.
492, yeah. 0.49, 4.92, yep.
4 point... No. Sorry.
Yeah?
It's 1.96. 1.96, sorry.
1.9.
Yeah, making America... We're making America smart again while hopefully he's eating a dinner that doesn't have, like, red 40 or something in it.
I said 1.96.
It's 1.96. Thank you. Okay.
Why is it? Oh, whoops.
Feel like for people out there looking to take FE and PE exams, this is a perfect stream to watch in your free time. 100%, yeah. You'll learn some shit, dude. Okay, acceleration is equal to this, okay? So
Yeah,
acceleration is equal to 1.98 meters per second squared. And so now we need to know how far does the mass move in 1 second? Okay.
Wait. Discrepancy.
Sorry?
1.98 is not true. 1.96 is fine,
96. Sorry, I'm having
That
a
was
stroke
almost
today.
going to be a redo problem.
It's okay. 0.08. Yeah, I'm just gonna fucking round this to 2 anyways. Oh, bratwurst and fries. Nice. I love sausage. Yeah. Okay, so I have an acceleration. I have that time is equal to 1 second, and I'm looking for delta x, right? And I assume this thing starts at rest, like it's at rest and then it starts like moving. So I'm gonna say that
Because the at teach was there, the black
Vegetables.
over and then it starts.
these are 0 vegetables, dog. Okay. All right, so this is the equation we use. Delta x is equal to v naught t plus 1/2
There's this thing
AT
called
squared.
veggie tables.
Veggie tables. What are veggie tables?
It's not a new thing. Apparently, it's required to live.
Oh
You know.
my god. Yeah. 1.96, 1 squared. And so now I get delta x equal to 1. Yeah. 1 meter.
Well, point
Yeah. Well, whatever. I'm just calling it 1.
0.98.
Because look at the answer choices.
Oh.
Answer choice is 1. And you're done. There we go.
Web help screenshot the physics one here.
Let me help out a Darsh or someone, because they have been waiting a bit.
Oh, and another integral now.
Oh,
You're
wow.
staying longer, so you're
Ship.
gonna get more problems.
Lurking male. Lurking male. I'll
What's
make...
the chemistry one too.
And a chem... Who had the chem one? Where's the chem one? Sorry.
Equity.
Okay. Equity, if you're in the chat, you need to say hi to me. You need to tell me that you're here.
And you have a integral problem, and you have a
We got so many problems today.
Physics problem. Physics, chemistry, integration. The rest of Adarsh is the rest.
All right, let me hit it. Let me help Adarsh out. Adarsh, what's up? You here? You in the chat, Adarsh? And Equity's here. Okay, nice. You're both
I
here.
see Adarsh. Yep.
Okay, here. Let me do Adarsh's real quick, and then Equity. I will do
R.
yours. Yes. Let me do Adarsh's. I will do Equity's.
P,
Okay.
R lies on the line with equation y equals f plus b, where b is its constant. The point with coordinates 2p5r lies on the line with equation y equals 2x plus b.
Mm.
If b is not 0, what is the value of r over p?
Oh, this is kind of tricky.
It's not
Okay.
too bad though.
Okay.
We know rules here. It's not bad.
Where b is a constant. Okay, so if a point lies on an equation, that means that if I sub in p for x and I sub in r for y, you should get like 1 equals 1. Like you should get a true statement. So in this case, you're gonna get that
What I'm saying
r.
is what the first thing that came to mind was point slope form, but
No, I'm gonna do it this way though. Like so, look, if I plug this into
no,
here,
I'm just saying the first thing that came to mind
yeah,
was point slope form.
Yeah.
Obviously, yeah.
let's do it.
It must
So
also be
r is
y
equal to
equals
p.
x, yeah.
R is equal to p plus b. Okay, and then we say this point lies on this line. So that means that 5r is equal to 2 times 2p plus b.
Yeah.
Does that make sense,
and then
Adarsh?
If p is not 0, find r over p.
And b is not. If p is not 0, find the value of r over p. Okay.
Well, this is not bad now because I know what b is equal to.
I feel like I want to cancel
B's
out
value.
b. I want to cancel out b. I think I want to cancel out b.
That's
No?
the idea.
All right, so let's
b
do it.
is 5r minus 4p.
Well, I can actually just do it this way. Let's just subtract the two.
Oh.
Could you explain it again, Dr. Gold? Yeah, of course, man. Okay,
Let's do
one
it
sec.
again.
Here, equation of a line, right? This is y is equal to x plus b. So if there is a point, let's say, for instance, like 2, 3, or let me
Comma.
use different colors. Let me do some things here. If there's like this, let's say there's the point like 1. I don't know. Comma. Yeah, let's do 8.
Let's-
Yeah, let's do 8. Fine. Right. 1, 8. All right. That means
8.
in this equation of this line that if I sub in 8 for y, and then I say, one second, let me just copy all this. And then I say is equal to x plus b. I'm gonna now substitute in 1 for x. Okay.
Now.
So
if you still
this
don't
has
understand
to
it
be
now,
a true
let me also
statement.
give it
Yeah.
Let me also give a reason. Let's do a reason here. If this isn't made yet since yet, we can easily do a reason. Point slope form.
Sure.
Point
Sure.
slope form will return this. Will backwards return this.
Yeah.
Well,
So
did that
point
return?
point slope, right, is that y minus y1 is equal to mx minus x1.
Is
that what it is?
Yeah.
And so you leave y, so you get y minus, in this case it would be
Minus
8, is
8
equal to the
is-
slope, and the
I
slope
know
of this thing
M,
is
we don't know
1.
the m value.
Well, we know the slope is 1
Right,
here if it's
yeah.
just x plus b, right?
Oh, by saying what you're giving
Yeah.
yourself.
And then this is x minus 1.
1.
Cool.
So so it's solve for y.
Yeah.
And then we can
Y is equal to x plus 7.
x plus 7, which is b is 7, which we said b was 7 over here on the point.
Right,
list.
and that works here as well. Yeah, 2 different ways to do it.
So yes, therefore true.
The issue here, Adarsh, is that they didn't give us numbers for the points. They gave us variables. And so if they give us
Fine.
variables, we need to keep these things as variables as we're doing shit, okay? So all I did here for P and
Therefore,
R
therefore,
is I
R
subbed in
equals B plus
I subbed in P for X and I subbed in R for Y,
for y.
and I got this.
And
Then for
2P
this
for
point
X
on this line, I substituted this for X, and then I substituted this for Y. And that gave me this.
Okay. Before we continue,
Yeah, before we continue.
Josh, you good?
Adarsh,
Josh,
you
you
get
good?
this? That makes sense? Also. Oh, okay, cool.
Okay. There we go.
And I'm gonna simplify this. I'm just to multiply the two out. So, if now we decide
Yeah.
to subtract these equations from each other, you're gonna get r minus 5r, which is gonna be negative 4r, is equal to p minus 4p, so that's negative 3p, and then we have b minus b, which is 0.
And yet it is cancel.
Good. So yeah, and then the next thing we're gonna do. Do you understand, Sadarsh? This is a way to like solve systems of equations. It's pretty cool. I'm gonna divide both sides by -4. So that's gonna give me r is equal. Yeah, my bad. Is equal to 3/4 p, and then I'm gonna divide both sides by p, and so r over p is equal to 3/4.
Yep, and that is what they're looking for.
And there you
what
go.
they're looking for is in the bottom.
And that is r over p. Yeah.
That's dope.
It's cool.
Not
cool
the
question.
hardest thing at first. Okay.
I love that finally, like, we've gotten a streak of, like, questions that don't, like, hurt me in, like...
Do you want to do chemistry or physics first?
Let me help out equity.
Goodness is.
Equity. Yeah,
Ooh,
help out
hey,
equity.
You asked for the Facebook questions. You got one.
Someone give me one of the Facebook soccer mom questions?
Surprise, motherfucker.
I
God
typed it off,
damn
though.
it. God.
It's
I will do it. I will do it eventually. Just, yeah, give me a second.
okay, but be warned. This has a trap in it as well.
Oh, it does have a track. Okay. Okay.
What I'm saying is it's impossible.
Whoever keeps
equity-
posting them, I will find you and I will
It's
hurt you.
impossible.
I will kill you. I will hurt
It
you.
has impossibility to it, by the way.
All right, let's see. All right, one sec. Let me pull in the
Physics
equities
first or
question.
chemistry first?
We're gonna do chemistry first. Let's do it.
Okay. This one. Oh, another help. Sheesh. Oh, ooh. Here's kinematics. Ooh. Okay, kinematics incoming now. We need to stay. So
Is this
several
is this
problems.
kinematics?
No, this
No,
is
this
not.
is-
I'm saying this is kinematics incoming.
Oh, okay, cool.
I'm watching Discord.
Oh, okay.
I'm
What's
doing
up,
all-
equity?
I'm
gonna do this one for you. I hope you're here.
So you can focus
All right.
on doing the math.
Silver nitrate reacts with ferric chloride to give a silver chloride AgCl and FeNO33. Okay, blah blah blah, whatever. Find out what the fuck happens. Okay. So write the chemical equation. Okay, what's up, equity? I'm gonna do it. So we have AgNO3 is reacting with FeCl3, and that's gonna give me AgCl plus FeNO3 3. Okay, let's see if this is balanced. Fe is good. Ag is good. Cl3 is not. So I have three chlorides here. So I need 3 chlorides here. So I'm gonna put a 3 on this one. Now I need 3 Ags. So I'm gonna put a 3 on this one. And actually that solves things out. Because now I have 3 NO3s and I have 3 NO3s. So everything's good. Okay, cool. Treat the NO3 as like its own thing. Like a solid thing. What does Famish say? I have 2 phones that are similar and I'm switching the motherboard to access the other phone. Dude, what? Why are you switching motherboards on phones? That's intense, bro. Dude, what?
Okay.
Okay.
Now, what's if you want to put some notes in this as well?
Yeah.
A solution containing 25 grams of AgNO3. So there's 45 grams of that substance.
Yeah.
And there's 45. There's 25 grams of that substance and 45 grams of the other substance.
Yeah. So what I always like to look at, I like to look ahead on these questions, equity, and I look at like which thing am I eventually having to determine, and it's the amount of AgCl. Okay. Because what they do here is they say which reactant is limiting. The way to figure out which reactant is limiting is to start with your 2 different, reactants, the 2 different things you're starting with, and then see which one produces less of a certain product on this side. But I like to pick the product. So you could do either one of them. But if you look ahead and you know that you're going to have to figure out AgCl, just pick AgCl. So here's what I'm going to do. I'm going to set up 2 situations. I'm going to say how many moles of AgCl is equal to, and then it's one of these starting amounts. So we have 25 grams of silver nitrate. I'm going to say 25 grams of AgNO3. And then I'm going to do another situation, which is how many moles of AgCl is equal to 45 grams of FeCl3.
And what we could do is we could be nice about this and do how many grams of AgCl and how many grams of AgCl.
We'll do that at the end
And then convert
because the first one's asking for a number of moles, and then this is fucking.
What I'm
cake.
saying is if I'm just saying do the grams first, because grams we have grams and grams. That requires
no.
conversion.
No. No. You have to go grams, moles, moles grams, and I'll show you why. There's a mole ratio you have to use. You can't convert straight grams to grams. So I'll show you why. This is the chemistry part of things. So I'm trying to get, so here's where things are like interesting. I have grams of silver nitrate, and I'm trying to go to a completely different unit, which is moles of a completely different thing, AgCl. So I have to do two transformations. I need to somehow go from like grams to moles, and then I also need to go from like silver nitrate to silver chloride. So the first thing I'm going to do is I'm going to convert this into moles. This should always be your first step. Just convert to moles, because once you have things in moles, you can start doing cool stuff. So I need to know what the molar mass of silver nitrate is, which I'm not going to add up because that's just dumb. Silver nitrate mass. I'm just going to Google it. Whatever, 170. We'll say it's 170. I'm using simple numbers. Okay. So I can say 170 grams of AgNO3 is equal to 1 mole of AgNO3. And now, so cool, we've gotten to moles, right? But it's of the wrong thing.
The wrong one, so that we did convert.
So now I need to do the conversion between moles of AgCl and moles of AgNO3. And what I see is
conversion ratio.
that moles is always this number in front. There's technically like a 1 in front of here and there's a 1 in front of here.
3 is 3. So 3 is
right.
3.
3 moles of AgNO3 is equal to 3 moles of AgCl. So I'm going to say 3 moles AgNO3 is equal to 3 moles of AgCl. Cool?
So 1
All
mole.
right.
Well, we don't want 3 moles. We want 1 mole of 1 mole, though.
Well, yeah, no, that's fine. Watch, the numbers will cancel out. You'll see.
I know, I'm just saying.
Okay,
We
so
can
then
simplify that to 1 of
I need, what is it? FeCl3?
Yeah.
FeCl3 mass.
L3.
162. Okay. Okay.
162. So 1 mole, 162 grams.
So 162 grams of FeCl3 is 1 mole of FeCl3. And then now we're going to multiply that by the mole ratio, because I need to convert from FeCl3 to AgCl. 1 mole of FeCl3 is 1 to 3, yeah. 1 mole of FeCl3 is equal to 3 moles of AgCl. Okay.
And cancel.
Yes. So here's the nice thing, right? Yeah. So you're going to get like, what is it? Like grams of FeCl3, grams of FeCl3, moles of FeCl3, moles of FeCl3, and you're left with just moles of AgCl.
45 times 3 over 152.
Good, exactly. So, yes, that's right. The next thing you got to do is you just got to multiply everything on the top and then multiply everything on the bottom and then divide them by each other.
Well,
yeah, you want to just
I can do it.
Yeah, can you just give it to me?
135, 162. That's what I can give you.
For what?
135 over 162.
Oh, yeah. No, I want the final number.
I can't decimal it for you. Of course
Okay.
not.
All right.
I can give you a number to work with.
45 times 3 divided by
Give you the number
162.
that's-
It's okay.
Yeah, though.
It's okay. So this is equal to
nice.
0.83
Oh,
moles
wait.
of AgCl. And then this
Oh, I
one
should have
is...
decimaled it. I should have
It's
decimaled
okay.
it.
Could
'Cause if
you
I
have...
didn't use multiple grades,
Yeah,
I
I mean, that
decimaled
looks like a nice number, no?
I know. I
And
realized
then this is going to be
That was the
0.147.
7th number. Even better.
This one sucks.
That's the 7th number.
Okay. So this right here, right? So when they say like which one is the limiting reactant, okay? The limiting reactant is whichever thing you started with that ended up
You
giving
can't
you
do anything.
less of the products. So in that case, that was this one, right? That was when we used the 25 grams of AgNO3. That gave me less moles than using that. So I'm going to say, okay, the limiting reactant is the AgNO3. What's the number of moles AgCl that could be obtained? We've already done it, right? We've helped ourselves out because we've already looked at this thing. And so that is going to end up being
And then maximum number of grams for converting,
0.147.
so that was converting.
And then if we want the maximum number of grams, so this is cool because this is
By
moles
the
of
way,
AgCl.
That's just a
Sorry?
number. That's just a number.
Oh, okay. Moles.
0.147 what?
Moles.
Yep.
Okay. So now I can do the molar ratio, which I can say 1 mole of AgCl. And then what is that? What's a mole of AgCl equal to?
Sit down.
Molar AgCl weight.
And weight is
143.32.
Mass is helpful.
Yeah.
Weight is nothing.
I
Weight is
know.
physics.
Okay. So whatever. All right, so I'm gonna
Well,
multiply that by
yeah.
143.32,
That's
and that's gonna give me
that's only a
21.07.
I didn't-
Right, this is grams per
it didn't
mole. You're right.
answer.
Yeah. Okay.
So
So that's
AGL3. Yeah.
yes. So this would be 21.07 grams. Okay.
Yeah.
This is the other tricky part here. They say, okay, well, how much of the reactant in... Wait. Limiting reactant is something that reacts. So how's that AgCl? Yeah.
That's exactly right. How is it AgCl? It's not. It's AgNO3.
AgNO3 is the
different.
limiting reactant. Yeah. AgNO3, this is the limiting reactant. This is the amount of things that are produced from it.
The
where
production
it
is
comes
what we
from
care about
chlorophyll.
when we're looking at. To find what's
Now,
limiting,
if
find what's
this
not.
is limiting, right, the other thing is excess. So that tells me that the other thing I started with, which is the FeCl3, so FeCl3 is excess. So now what I want to know is that, okay, cool. If I produced 0.147 moles of AgCl, how many
With that
moles
same
of
amount we
FeCl3 did I need? Yeah, how much did I need? So I'm going to say, okay, cool. How many moles of FeCl3 did I need to produce 0.147 moles of AgCl? And this is great because this is now just a mole ratio thing, right? Because look, so I know 3 moles of AgCl
Is one of the other.
good is 1 mole of FeCl3, and then I know that 1 mole of FeCl3. Yeah, I'm running out of room. Fuck.
Is 1 mole of one of FeCl3.
No, is how many grams, right? Because we want. Wait, sorry, I want grams. Yeah, sorry, I fucked up. I fucked up. I want to know how many grams of FeCl3.
I mean, mole again because we don't need.
Yeah. And
Rewrite the question.
FeCl3. Do we have a mass for FeCl? Did I not do the mass for it? I didn't. Fuck. No,
You
I did.
not. That was
I
one
did. No, I
thing.
did it here. I did it here. It's 162.
Okay.
Okay.
Wait. Okay. We're just
Right?
Okay.
So 162
54,
grams.
So,
So we do.
54 times 0.147. Whatever that is.
Good. Okay, yeah. Time because
I
is
just
that
did my
54?
calculations, I know.
Oh, it does work. Okay.
54 times 0.147.
Yeah, I got you. So okay, so
don't know what
this
the
is
number is.
equal to 7.94 grams was used. Okay. Of FeCl3.
Which isn't helpful. So we no, it's
No, because we want
partial.
we want the amount that will remain. Okay, but I started with 45, right? So started
Oh.
with 45. So if I do 45 minus the amount I used,
With your number.
we should get the amount that we are left with. So 45 minus, and that gets us 37.06 grams, and you should be done. Nice.
We had to do one more. We had to do one more part. I don't know if this will come up on any test, but it may. At what point is it equal to gram? So at which,
Sorry, what?
So-
At what point is it what?
if we give 45 grams of one, how much do you need for the other to be exact? Or 25 grams of one, how much do you need the other to equal out and not have a limit? Not have a limiting process.
Well, we already know that 7.94. Oh, you mean if I had 45, like how much of the other one would I need?
Yes, because
Yeah.
to make it equal, so we would not have a limiting number at set.
You could do that, but yeah, that's another good question.
No, I'm
but,
saying that might come up on a test or something like that.
It could.
Just it's another type.
Okay.
So we got Sandfritz, we got Kinematics, we got another one from default user. We got a
Equity, did that help
another-
you out? Equity, that makes some sense to you, dude? I hope you're watching that because
Visits,
that was a lot of
integration.
time.
Yeah. So we have chain tritzes, we have a kinematics, we have a physics, we have an integral, we have
Ooh,
basic
okay.
algebra, and then we have the Facebook
Here,
problem.
let me do the integral, and then I'll do the physics, and then
We did do the math one first, default user. That was, and we did that.
Yo, Gold, are methods and procedures the same thing in Java? I don't know. They sound like they're the
Oh,
same
and another
thing.
integral. You have another integral now. You have 2 integrals now.
Thanks, Drynose. Yeah, Drynose has a final. Yeah, what's up, Drynose? Yeah, let me do this one. Then I will do...
This one's nice.
And then
What's the
default
trap?
user, I
What's
can
the
help you out
trick?
with yours. after that. Here, let me do this one real quick. This is not too bad.
What's the trick?
What's the trick?
Oh, I see. You have to read the Twetson. You have to read the Twetson before we solve it. Trick is that
oh.
simple. It's an easy Twetson once you read the Twetson.
Are they saying what's the derivative of this? Sorry, I didn't read the whole
Find
question.
the derivative. That's what they're saying. Yep. Find the
Oh,
derivative.
find the
of question.
derivative. Okay, this is not bad either. Okay.
Of an integral.
So
I had to
yeah, this is
reread
called the
that.
this is called the fundamental theorem of calculus. So if you have ddx of the integral from, I think it's like whatever, like a to x of like f of t dt. This is the same thing as just f of x, and then it's like times whatever this derivative is. Actually, so here, this is what if because the problem is like this could be a function of x. So let's say this was a function of x, then this is equal. Well, let's sorry, a new function g of x. Now this is f of g of x times dg dx. Is what it is. I think this is like the full form of it.
So this is the function of t inside there. So
Yeah, it's okay. Oh, Zach says the difference is that in procedures are methods that oh, that makes sense. Like procedures don't return anything. Yeah, that kind of works out. No return. Yeah, no return. No. Okay, so for this one, I mean this is simple because this isn't fancy. So you literally just plug this in. So you would say that, okay, cool. So df dx is now just equal to the cosine of x squared. I think that's all you have to do. Literally, I think that's all you have to do.
no, what the 3? What the bounding? I see a 3 there that wants to bound this.
Does the
That
3
function is not
matter?
bounded on 3.
Does the 3 matter?
Does it? It flips the equation because 3 is there's 3 to add.
Do I have to do 0 to 3? Is that what I have to do? I thought I'd literally just do this.
I thought so, but I see the 3, so I didn't know if it was bounded or not.
One sec. Let me look at like fundamental theorem of calculus.
Yeah, wondering. So, it's like, what with that? Number 2. Above,
Yeah,
yeah,
this-
above for the.
Was it here?
It was at the top. I think. Too.
Right. No. I'm right. It doesn't matter. It doesn't matter if that's a 3.
Really?
Yeah.
No, there yet.
Because it's right here, right? A to x of f to t dt. F prime of x is just f of x.
Is out. Nice.
Yeah. The urge to post a question of 2 plus 2 is crazy right now. Don't do it.
That was easy than it looked.
Yeah, that was easy. Happy with that.
Let's do the other one then while we're here. If it's still here. Yep. Let's do the
Which
other
one?
integral then while we were doing it. I
let me
like the
pa-
integral. From,
You like that? Okay, this one actually isn't bad. Yeah. We'll do this integral and
it's
then
not.
default user. I'll do yours next, and then I will do the physics question of the momentum. Okay.
the physics question from
No, there's another
the
physics
ship
question.
or
It's
the
a-
kinematics.
Whatever, the one is sooner. Okay. So
Uh-huh.
yeah, in this case, this is an easy one because anytime you see something that you could like just replace with u, for instance, let me just like replace this whole thing with u, and then if the derivative of it shows up somewhere else, so the derivative of x is just a constant, it's just 1 that shows up somewhere else, so then you're good. So I'm gonna say
It's an easy then.
this is easy. Let 4x plus 6 equal to u, then du is equal to 4 dx. Or we say that du over 4 is equal to dx. So now you can rewrite your integral here as, I'm not going to do the bounds yet, okay. And then this is u
Of course
to
not, 'cause
the
it's
u to the
denoted
1/3, and then dx is now du over 4. So this just got slammed in here. So I can
Okay.
pull the 3/4 out. So this is 3/4, and then this is the
Integral
integral of
bounded.
u to the negative 1/3 du, which
And then
raise
let
the
u
power,
equal
divide
right
by
up.
it. So that's going to be u to the, what is that? U to the 2/3?
What? Yeah.
Over 2/3. Which is then going to be 3/4 times 3/2 times u to the 2/3. But what was u? U was 4x plus 6. So that's now going to be 4x plus 6 to the 2/3. And then this is, now we have the same bounds, which was from
Not
negative.
yet.
Yeah, we
Got
do.
something.
What did I
You have
forget?
two bounds. You have a problem bounding right now.
What's wrong with my bounds?
What are you bounding? Are you bounding U or S?
This is me bounding X because I plugged X in.
You can't bound X. There's a U in there. Oh, there's a U in the other one. Sorry.
No. This
I was
one was
saying that
bounded from like
you
something
mo-
with
you moved
you and
everything
something
around.
with you.
Moved
Yeah.
everything around.
And then I plugged it
I
in.
didn't see the arrow.
Oh, you're good.
I didn't see the arrow.
So that's 9/8,
9.
and then we're gonna say so plugging in 0. That's like 6 to the 2/3 minus. Was that -4? Sorry. Yeah, it is -4. Minus, and so what is that? That's -16 plus 6, so -10 to the 2/3. Right?
Mm-hmm. I don't know those numbers at all. No, actually, That's
So, yeah.
2 to 36. The others, no, I don't.
It's just whatever. It's just this. It's nothing pretty.
The fundamental theorem of calculus said it did not.
Yeah, the real Colonel asked, a good question, by the way. Okay, said, why did the 3 not matter? I don't know. It just doesn't.
Fundamental theory of calculus says it does not.
There's
You'll prove it
probably
if you
some
want to.
theorem to this.
There's a proof. There's probably a proof that goes into it.
What about x -3/2? What is he talking about, x -3/2?
No idea.
What are you talking about, x equals -3/2? What was wrong with what? Wait, what? Fembox, what's up? Did I do something wrong?
I don't know. So I'm gonna pass around that.
Where was the 3/2? Three halves came out here. And that just gave us 9/8. And then I plugged in, right?
When does it matter? None of the cases.
Yeah, they're
Because
talking about
fundamental
this.
calculus, theory of calculus
Yeah.
said it didn't.
He's talking about on this one, for instance. So why did I not care about the 3 here, right? I think as long as a is a constant. Oh, x equals -3/2. The integrand goes to infinity.
Oh,
Oh,
no. This is annoying now.
no.
This is that annoying.
No, dude, I'm not doing it.
No, God!
You realize that, did you? This is a problem.
Okay.
This is more messy than we thought.
Yeah, this gets a little bit messier because you need to break this out into. You're right. There's a discontinuity. You have to do this from like -4 to negative. Well, you have to do this from -4 to a, plus a to 0, and then it's the limit as a approaches -3/2. Yeah, Zach says derivative of whatever. I'm not gonna do this because that's gonna take too much time. But yes.
Oh, you do not like that anymore once you saw that?
No, I have too many other things to go through to do that. But that's what you have to do. So go do it.
I'll check it
Basically, you'll get to this, and then you need to take limits as a approaches -3/2 for each of these.
It's probably like that looked too easy for that.
I think
the final
no, I think it's
okay.
fine. I think it's fine here, right? Because -3/2 will be continuous here. That won't mess us up. You are right,
Really?
Femvox. Yeah, Femvox is right that the integrand would go to infinity, but that's gonna get knocked out once the power goes positive. Yeah, I mean you are right. So that's like technically the very safe way to do it. But I think it's the same result. Okay, where was the other guys? The other new student we had.
Which one are you talking about? There's like
I got it.
a lot.
I got it.
We
I
have
got it.
this ship taste.
Let's see it. All right, this
We're
was it.
doing
This,
Kinematics. Oh, we're
this
doing
was
that one.
this was from default user. He says, "I
Yep,
know
I
you
see.
said to avoid the parentheses, but I don't know where to start, or I just gotta distribute. I feel like I could solve it myself, but I want to see what you do in this." Okay, cool. Oh, okay. Well, in this case, you kind of do have to distribute. Yeah.
No, do you really have to though?
Do you? I'm pretty sure you do.
I'm trying to make the taste. I'm trying to see if I can make the taste where you.
I don't think you can. I don't think you can't. Yeah.
I might be able to get around. Trying to get around it. Oh, I can get around it. I can get around it. On the second one, I can get around it. I'll show you.
On the
First
second
I
one,
cannot.
you can get.
I can't
The
get around
second
the
one, you
first
can get
one.
around it.
I can get around the second one. I can show you.
All right, what are you gonna
annoying,
do?
but it's
Okay,
around.
but he's not gonna do this. He's like a high school kid or like middle school
Nope,
kid.
but I can get around it. I have to.
All right. In these
You have to take
ones,
over by 5 and get around it.
what you're gonna divide by 5, and then
Yep. Because then they can do stuff. move that term with the 4 over, divide everything by 5, and then you can then you have that left side ready to move everything back over if you need to.
Yeah,
You
okay.
can, but it won't help you.
Yeah, that's such
It
it's a roundabout way. Yeah. So in these ones, you do need to distribute. So this would be 4x plus 36. Now here's the key thing. This is where people get things wrong. This minus 5 has to hit both of these things. So this is going to be minus 5x, and then it's minus 5 times minus 7, which is going to be plus 35, is equal to 73. People will always get this wrong. They'll just say, oh, minus 5x, and then they'll say, like, oh, minus 35. But no. That's wrong. This minus 5 hits both of these things. Okay? That's the key thing you need to remember here. That's where they try to mess
Plus
with you.
71. Negative x
Okay,
is
and at
2.
this point, yeah, combine like terms. So this is negative x, and then this is plus, what is that, 71?
71.
Is
71.
73.
So x is
Minus 71 minus 71. Negative x is equal to 2. So x is equal to negative 2, and you're done. Yeah.
And the other one.
That's dope.
Okay. Not so
Now,
bad.
let me
right?
make a taste. Let me make a taste that does something neat. Now, to say on these tastes that it's always that when there's 2 of them, it's always a taste where you need to distribute. That is not true. To
Okay.
say when you have 2 of these happening, it's not always a taste that you will need to distribute. Let's take this example. Take 5 times 2x plus 7 plus 4 times 2x plus 7 equals 65.
Uh-huh.
Or take 5 2x plus 7 plus 4 times 4x plus 14 is 65.
Oh, you can pull it
In
out.
those
I
cases,
see.
you don't have to distribute.
Right. Okay, one sec. Let me just run this in.
I just combine everything into one set of parentheses, etc.
Arms are locking up. I need more electrolytes.
Aren't you going to do the other calculus one? The other physics one?
This is the other physics one, isn't it?
No, it's not.
There's another
one
physics
I'm
one?
mentioning.
Wait,
Yep,
what
you have to
other
look at
physics
it.
one is it? Where is it?
A ship is floating at drafts T to the F, T,
Where is
something
this?
subscript
Oh, this
F.
is
It's in
way
the
up. Oh, this is from Lurking
web
Mail.
help. Yes, I marked all the Twetsons with Twetson
Oh,
marked.
thank
or
you,
with
thank
a
you.
Twetson mark, exclamation
whatever.
mark. We haven't.
All right, let me do this.
touched it yet.
In Visio, then I'll do
Twetson
yours.
mark,
Let me do this one real
we
quick.
touched
This
it,
one
but
was
we
first.
we stopped on it.
I get it. I understand.
I marked
Okay.
them. So
A ship is moving at drafts TF equals. Dude, what the fuck are drafts, by the way? This is where engineering starts like using weird ass like. Is draft like air, like a drafty window?
Why is that annoying?
Dude, what the fuck is M? Sorry, what?
You need to skip this one.
Dude, what the fuck are?
I feel
No,
like you need to skip that one.
No, it's okay.
Right.
I'll learn it. It's just this is engineering. Engineering, they start using like
That's
weird.
like weird.
Let me
It's okay.
one sec. Let me just throw this bitch in ChatGPT.
If you need to skip it, that's fine.
No, it's okay. Here, solve this, because it'll tell me what drafts are. I just don't know what drafts are. Okay. Longitudinal center of flotation, tons per cent. Dude, yes. This is what I'm talking about. This is where... No. Like, what's the trim? Sorry, what? No.
Surprise, motherfucker. Surprise, motherfucker.
Dude, no. These are
Wait,
just
wanna do another
hyper-specific engineering terms that I don't know. Yeah, no.
Let's do another calculus one now. A term is defined by the paramedic equations. It's just recently posted.
No. Let me do the physics. Let me do the
equations
let me do the physics one because I know that student. I know the student's asking.
I guess it's kinematics.
Let me do this one. I want to do this one.
Kinematics.
I'm gonna do this one. Let me do this one. Okay.
Okay, kinematics then.
Let's do this one. All right, cool. All right, you and your friend find yourself in an unfortunate situation. A shopping cart related stunt has gone wrong, and now your friend is stuck in a shopping cart on a crash course for your house with a speed of 1.79 meters per second. Okay. You are on top of the roof of your house, which forms an angle of theta equals that with the horizontal, and it's your job to stop your friend. Dude, this is nuts.
You know that the mass of your friend and the tart combined is the mass 46.5 kilograms, and there is a box with total mass of 48.6 kilograms on the roof. Your plan is to place the box on the frictionless rooftop and let it slide off the roof.
Let it slide off the roof.
8.81 meters above
And then
the
he's going to
ground.
catch
Your
the
friend is going
box,
to
and he's going to get
slide
slowed down by it.
How far up the roof do you need to climb in order for your friend to attempt to complete?
You done messed up,
Jesus. This is going to be a really involved question. Because there's so
Yes,
many
it
things
is.
going on. Okay. So this is meters per second. And then this is
It's frictionless. So
46.5 kilograms. And then this is 47.4 degrees. And
48.6 kilograms.
okay. And the roof has a height of 8.81.
Wrong. That's not true. That's not true.
Oh, sorry. This is
We don't know that.
8.81.
We don't know that height. We know that height. We also know something else. You know, mass volume.
How far up the roof do you need to climb in order for your friend to come to a
You
complete
know another
stop?
mass volume, by the way. You know the little m.
Yeah, whatever. Wow, this is involved. And then they're asking how high do I need to go in order for it to get slowed down by it. I wonder if I just want to use
just like
conservation of
that.
energy here. I might just use conservation of energy.
Is this not kinematics? Is this not, no? It's kinematics though.
No, it is
so-
kinematics. Yeah, okay. Next, you need to because you don't know like
You're supposed to do
you don't know
kinematic
when he's gonna catch it.
equations. You're supposed to do kinematic equations on this, probably.
One sec. Okay. How far do you need to climb in order for your friend to need to come to a complete stop? Okay. So, this is a very challenging question, but I'm going to define some things. So, this is, for instance, going to be when he catches. Okay. And what I need... Oh, no. Okay, yeah, when he catches... And here I need his velocity to be equal to 0. Okay. So let's call this like M1, and then let's call this M2. Okay. So I need the momentum of this thing going in this direction to equal the momentum of him going in this direction. And then when those momentums combine, he will stop. Okay. So V total. Right. So what we're going to say is that M1 and here I'm going to write down a couple situations here. So situation 1.
Oh, is this cases?
Yeah, this is case 1. Case 1 is that it's at the top. Okay. Oh, wait, one sec. I need to let me copy this in somewhere else. So I need to grab just the diagram.
Well, that's annoying. That's neat, but not helpful.
All right, that's case 1. No, I thought I copied this. One sec. Okay. There you go.
You seem.
Here. So case 2 is going to be right when the block is here and it's falling. Okay. Cool.
Well, and you need both cases because it's going to be the amount of time it takes to do both cases.
Yeah, exactly. So I need the amount of time it takes for it to like travel horizontally to hit my friend. And then here, this is going to be case 3, which this is now gone. Okay. This is also gone. And I'm going to have, so here, let me move this. Let me make this white. Right. And then we're going to have case 3, which is that him, my friend, and the box, M1, are now together. And then this velocity is equal to 0. Here, yeah, and V1x is not going to change. Okay, cool. So here, V1x. Yeah, I got it. Okay, all right. So here, M1 V1x needs to equal to M2 V. Cool. And okay. Interesting. I don't think I think this is actually easier than I thought it was.
What do you mean? 40
Because-
years? What?
No, that's a bug, Shantrix. That's a bug. It's okay. That's a bug.
So what do you mean?
Okay.
By
This is
easily
cool.
thought?
No, this is really cool. Okay. I am going to use conservation of energy here. I feel like I am. Because I want to know what the velocity of the thing is.
Easier than you thought it was going to be.
Because I don't think I care about the timing and stuff. Do I know the height of the person? No, right? No.
No. Nor do we care, yes.
Okay. So let me think.
If we cared,
'Cause
they would have given
all
it
that matters is that the velocity of this thing in the x direction equals, so the momentum of this thing in the x direction needs to equal the momentum of this thing in the x direction. So that when they combine, the momentums cancel each other out and the thing stops. And so I'm not even sure the height really matters here. Because we don't know where he's starting. That's the issue. We don't know where he's starting. So I can just do, I think I can just do MGH here, right? So watch this. So here, right? So whatever, so how far up the roof? Okay, we'll get that. Let's just get the height he starts at. So M1 G times H is going to equal to 1/2 M, and I'm going to call this V1 squared. This is conservation of energy. So the amount of potential energy in the height. Well, first of all, in Visio, am I allowed to use conservation of energy? I could do this with kinematics. It's just
momentum and kinematics in the title. So take it as you will.
Do I want to use kinematics? It's just it's annoying to use kinematics.
Why?
Because you have to solve for the acceleration of this thing downwards and then divide, and then you got to do like kinematics equation to get the distance that it travels, and then that gets you the velocity, and then you have to components it.
Okay.
Yeah.
That doesn't sound too bad. From what I know of physics, it doesn't, but
it's pretty bad.
that's up to the person that set the question. The person who set the question.
Okay. If I want to use straight kinematics, let's just do it. I'm going to call this X, all right? So I'm going to say that, so V1 squared is going to equal to V0 squared. This is going to be 0. And then it's going to become, it's plus 2. There is a weird proof for that default user. This is 2, and then this is going to be A, and then this is delta X, okay? And then to figure out A, A is this question, okay? This is an inclined plane. So if this is gravity, then this right here is going to be M1G M1G sine theta. And that's equal to M1A. Oh, so the M1s cancel. Oh, very cool. So AH is equal to G sine theta. And that's the acceleration of this thing. So V1 squared is equal to 2 G sine theta. And then delta X is how far up the roof he's going. Cool. I think that's right. Now, in order to figure out the velocity in the X direction, right? That's going to be cosine theta. So I'm going to say that V1 is equal to the square root of 2G sine theta delta X. And then V1X is going to equal V1 cosine of theta. So this is going to equal to V1. So sorry, it's square root of 2G sine theta delta X. And then this is times the cosine of theta. Okay, so that's the velocity of this block in the X direction once it has been carried up a distance delta X. That's the velocity in the X direction. And that velocity is not going to change as this thing falls down. I don't even think the height is really needed. Because we don't know how far he starts away from the house. Yeah, we don't know. Okay. So then this times M. So M1, all of this needs to equal M2V. So now we're just solving for delta x, right? So I'm going to get that m1 over m2v. And then this is cosine theta. I have to square things because we're trying to get delta x out. So m1 squared cosine squared theta times 2g sine theta is equal to m2 squared v squared. And then, well, there's a delta x, so I'm going to move that under. Okay. And then this is all equal to delta x. Okay, cool. All right, now we're done. Now we just solve. Do you know the answer to this one in Visio, by the way? Do you have the answer to this? Curious. So M2 was, so we had, let me put the calculator up. Okay, 46.5 squared times 1.79 squared equals that, divided by 48.6 squared divided by 19.6, and then we're gonna divide that by the sine of 47.4, and then we're gonna divide that by cosine of 47.4, and then we're gonna square that. So I get 0.44 meters for delta x. Dude, that's from 1984. It's not real. All right, let's see. Oh, that's a good one. Blocks and springs.
Oh, more? Yep, more.
Yeah. Oh, we exceeded the maximum time.
Did you finish the other one then?
I think I did. I want to see
The
if
answer they asked for?
no, I didn't answer the spring one yet. One sec.
No, did you answer the how high?
I think I did, but I gotta check. I think he's trying to check for the answer. He says yes, that's right. Wow. Okay. Did you understand this in Visio, how I did this? Does this make sense to you? I will download this for you if you want.
We have a tact list, we have a spring, and then we have the fun one too. Fun ones.
Yeah, it was just pretty difficult.
Answer.
It was. Yeah, especially if you're using kinematics. But very cool question. Yeah, so I have it for you right here in Visio. So in the stage chat, there's a screenshot PNG if you want to do it. I might have to go to dinner actually. Sorry, my sister's been waiting. She just flew in.
Yeah,
from New Zealand.
it is 15 till 10. Yeah.
Yeah, my sister just flew in
Eastern
from
time.
New Zealand, and she wants to get dinner.
Well, you said you were gonna stay till all the problems are answered. That was a very, very
yeah, but
promise. That was a promise you did not keep.
I did promise that, but also it's been, how many hours has it been? Like 2 hours and 45 minutes.
Almost 3 hours.
Almost 3. I might just do this one last one, and then I got a piece.
We have 1, 2. Let me count for you. 3. That's it. We're trying to get to the end. We have 3. That's it.
Are you counting the soccer mom question, dude? You counting the soccer
Yes,
mom?
4.
All right, one sec. Let me try this one. Okay, block with mass my falls onto and sticks to block X, which is attached. A short time later, they're at rest. At that moment, block Y exerts a force down on block X and block X. Okay, all right, cool. Which of the following correct? And MYG at the instant shown in figure 2. Okay. So block Y, and wait, we assume they're at the acceleration is 0 here, right? No. They're momentarily at rest.
At minute 2, they're at rest.
Okay, so we have to kind of like draw some force diagrams here. So sorry. So X is gonna have mx times g, but it's also gonna feel kx upwards on it, right? Because of the spring, right? And then force Y is just going to feel this is going to be F up, I guess. Yeah, this is F up. So this feels kx, and then this also feels F down. Now, okay. By Newton's law,
G3 is what?
by Newton's law, F down and F up should be equal to each other. That needs to be constant. That's just Newton's third law. The force of block 1 on 1 is the same as the block 1 on the other. So this is wrong. This is wrong. It's either this or this. So the question is, are the forces greater than MYG? Oh, this also has MYG. And this is MYG. Okay. Well, since this thing is down here, okay, but the... I'm assuming they're going to rocket back up, right? So the net force needs to be up. So if the net force needs to be up, that means F up needs to be greater than MYG. I don't think the acceleration is 0 here. Because it's not at equilibrium. If you think about this as like a supermass, this has K delta X pushing it up. And this has mg. Yeah. But it says they're momentarily at rest. So that to me does not say that they're going to stay at rest. And if they're not going to stay at rest, there has to be a net force upwards. So I think it's choice A.
Okay, that was easier.
Okay, dry nose. Okay, I think I can do dry noses. Blazing through
And then
everything.
and then you have a couple more from there. That's it.
Okay.
You're almost there.
So dy dx is equal to dy dt times... Wait, how does this work again? Fuck. Times dt dx? Is that what it is? Okay, nice. You're very welcome. Yeah. Very welcome for the help, dude. Is that how I do that? Can I just flip this and just say this is the same thing as 1 over dx dt? You can do it in 1 sec? Okay, cool. Well, I don't know. Is this negative 12t squared minus 16t? And then... can I literally do that? And then dx dt would have been negative 20t plus 6. So that's times 1 over that. So is it just negative 12t squared minus 16t divided by negative 20t plus 6? It's kind of nice. Yeah, this is live. Is this live?
That's dope.
It is live. Here, you can see your chat right there, dude. Yeah, it's real, dude. Okay. I wonder if that's true.
Two more.
Who else?
Chantrix.
Oh, I can't finish Chantrix.
So that's finished. What do you mean?
My brain cells are done. I love you, Chantrix, and I will try that one the next stream, but yeah, I'm kind of cooked.
Okay. Then you have the Facebook
All right.
one too.
Last question. Facebook soccer mom. 100 IQ question. All right, last one. Climber plus meditating boys plus climber equals 24. Okay. So I'm gonna say
when we start with an easy proof. Ready? By the what is the third one asking you to find? Before you solve it, what is the third one? What is the question asking you for?
x times y times 2z.
No,
Right.
that's how do you know it's 2z? And you know,
Well-
two climbers is the same as.
I assume they
times
are
two.
2 climbers. I assume they're 2 climbers.
How do you know?
I don't fucking know because
You're
it's
not divot.
Facebook.
Therefore, it's impossible.
Okay,
We're
but
done.
let's just assume. Let's assume it's x. Well, okay, that's z. So z times x times y is equal to question mark. Or sorry, it was 2x.
That's
2x.
Y though, because yeah.
2x. Sorry. So it's 4xy, right? Because 2 and 2.
What do you mean?
Yeah. This is the type
They
of
all-
shit we
they
get on
all-
assignments on Wednesdays. We got half days, so teachers don't got time to prepare.
Surprise, motherfucker.
Stop, AA Ron!
Okay, this is equal to 24.
The negation ones are.
And this
the
this
same.
says 2x plus z is equal to 22. And then this says that 4y plus z is equal to 22. And I want z times 4x
Why
times
is the
y.
two rock climbers 4x for?
What?
Why is the two rock climbers 4x?
Because there's 2 of these and 2 of these. So 2 times 2 is 4. It's really 2 and 2.
How is it? How are both of those the same though?
Because there's 2
How is-
meditating
how is-
guys and 2 this, right? 2 times that, 2 times that. It's the same thing, dude. This is like 4xyz.
You realize your mistake. Then you said
don't-
4. You put it as 4. Oh,
Yeah, 4x.
you put
Because
it as-
I was grouping it.
Oh.
That's okay.
Solve for z. You solve for 2x and plus 4y.
Yeah, sure. So, sorry. That gets me, that gets me 4y minus 2x is equal to 0, right? If I subtract these from each other. Right? So, x equals 2y. And if x equals 2y, then that's 2y in the first equation instead of y. You are right.
True.
Thank you. Thank you. Right. Okay. So then if I plug that in, that's 6y is equal to 24. So that tells me y is equal to 4. And if y equals to 4, z is equal to 6. Because then that's 16 plus z equals 22. So z is equal to 6. So 4 times 6 times 4 times 8. 24, 96 times 8. That's a big number, actually. Did I fuck
8
up?
times 4 is 32. Times 4, 64 and 28. 128 times 6. 128. 256.
Yeah, so it's
256
96 times
3.
8, right?
256 times 3. 780.
I got 768.
Yeah, 768. Yep.
768. Which is
Those are times
double
3
what
at
you
the
got, Femvox. Did I mess up? I don't know.
Did you? Let's see. 2x plus
Femvox
2y.
got 384.
Then it says 2x plus z. Then it says 4y plus z. And the last one says
1 second.
Z
One second.
times
I need to get this other assignment real quick
2x
before I
times
forget
2.
it. Did I already do this
z
one?
times 2y times 2x.
Question 12. And then there was this one. Let me download this one sec. Oh, I already explained this one. Pretty sure I already did this one sec. Clicker 4.
Unless you want to do scientists today, you're done.
I think
So-
I'm done. Thank you. I appreciate the question.
Unless you want to
Chantrix.
tackle the 2 I sent in there, you can, but otherwise you're
I'm
done.
chilling. Okay, cool. That's a lot of questions. Oh, you didn't see the 2 climbers? You messed up? Okay, all good. Okay, cool. Let's end off the stream. All right. Thank you, everyone, for coming to Actual Education Office Hours. Had a fun time working with all you guys. Appreciate all the questions. Yeah, sweet stuff. Okay, what we're going to do is we're going to go raid someone else. So if you follow us on Twitch, you'll get sent to another fun person who's streaming. But again, our streaming schedule, we're going to be on tomorrow, an hour later. So that'll be 5 p.m. Pacific, 6 p.m. Mountain, 7 p.m. Central, 8 p.m. Eastern. Be sure to follow, like, subscribe, all that fun stuff. You'll get notifications when we're doing stuff. Hard slog tonight. It was. Thanks for sticking with it, Femvox, as well. I appreciate you being here. We'll do Chantrix's sphere thing when I'm not, like, so burnt. Okay, let's go raid someone. Who do you want to go raid? You guys want to go see? Here are your options. We got building a hydraulic press to compress things. Griefer Madness. Star Wars and Astronomy Chat. I kind of like that. Unsupervised Spectral Domain Translation. I don't know about that. And Tinker Tuesday. I'm tempted to go see Astro. He's a cool guy. Yeah, gonna do astronomy news. Let's go say hi to him. Okay, cool. All right. Yeah, you're awesome. Yeah. Thanks for coming in, Happy. I'm glad you found us as well. All right. Enjoy the rest of your Tuesday. We will see you on Wednesday. Peace.